Hi everyone, welcome to Vedantu JEE English. I'm Diksha Kaushal, your chemistry master teacher, and today we are going to complete hydrocarbons here, where we are going to do alkynes and aromatic hydrocarbons. So basically from this part also, so many questions you will see in your exam because alkynes is a very important part, and there are questions based on aromatic and combination of alkynes and aromatic hydrocarbons. Okay. Yes, everybody. Very good afternoon, all of you. So, I hope so. Your preparation is going really well. And after that, we are going to jump on question practice. Right? Totally, we will do question practice after this of all the chapters. Right? Okay. So, I want to see that in the comment section that what you want from my side in the last, I would say 1.5 months. Okay. Yes. Okay, shall I start the session? Everybody in the chat box, shall I start the session? Shall I start the session? Is the board clear to you? Is my voice clearly audible to you? Am I clearly visible to all of you? Right, everybody? So that I can start this session. Yes, okay, bro. Okay, bro. Okay, so now let us start the session, right? Achha, one thing we were left with is basically you have three kinds of alkynes, okay? Alkenes. When we were doing alkenes, there are basically three kind of alkenes, very small part of alkenes this is, right? So we have three kind of alkenes. First is isolated alkenes. Isolated alkenes. What is isolated? That means I'll tell you. First is isolated, then you have conjugated, right? Conjugated means alternate double and single bond. Then you have allenes, cumulative allenes. Now, what is isolated, what is conjugated, what is cumulative? Let us see that. Okay, let us see that with the help of an example. If you talk about the isolated alkenes, right? Isolated alkenes are basically if this is double bond, this is single bond, this is double bond, right? After two steps, double bond can be anywhere. That means they are not adjacent and they are not alternate. In that case, they will be isolated alkenes, right? Double bond, but the position of double bonds we are talking about, right? Okay. Okay, Krishna, I'll make that. Okay, don't worry, I'll make that. Okay, you will see that in the next week. Now there is conjugated. Conjugated means double bond, then single bond, then you have double bond. This is conjugated. Next is allenes. In allenes, you have double bond, again double bond, again double bond. These are your allenes, right? Okay. So these are the three kind of alkenes. Now, firstly, let us talk about conjugated reactions. This we have done before also. Reactions of conjugated alkenes. If you talk about the reaction of conjugated alkenes, okay, let us see the reaction of conjugated alkenes. Very simple it is, very simple. 1,4 addition basically we are talking about, right? 1,4 addition we are talking about here, right? So here what will happen, right? You have CH, let's talk about C double bond, C single bond, C double bond, right? Let's complete the hydrogens here, tetravalency. So it is CH2, this is CH, this is CH, and this is CH2, right? This is the alkene, conjugated alkene that you have. Okay, take it anything. I am saying that I am adding HBr here. It can be Br2 also, right? The process is going to be same only, right? Okay. So now what I'll do, this is positive, this is negative, right? A simple way I am telling you, right? How to make the answer in a simple way, okay? So firstly, what you do, break this pi bond. I'm just going to write it here. This is, I'm just going to write it again here. This is CH2, double bond CH, single bond CH, double bond CH2, right? So what you're going to do here, break the pi bond. You need to break the pi bond here. once you break the pi bond, okay, you need to break the pi bond here. Once you break the pi bond, then what you need to do here? Once you break the pi bond, one will be negative, one will be negative. So basically either here electrons will shift or the electrons will shift on this side. I told you that always and always when you're breaking the pi bond, see the carbocation form should be highly stable. So if the positive is present here, only then this will be more stable, right? Okay, instead of positive here, right? So that's why positive is here, negative is here. So in that case where you have negative, attach H positive, right? Opposite will be attached here. So attach H positive here, right? Pi bond to is not present now, right? Now to this attach, two things can happen, right? Two things can happen. This is the compound, this is the compound, this was the reaction, right? Now guys, see this very carefully, right? Very important step I am going to do here. This is your 1,2 addition. Firstly, I'll tell you a simple 1,2 addition. How does it look like? So when you're doing 1,2 addition, first and second position, either you can make this as your final answer, CH2, CH, CH, this is Br and this is CH3. And this is the answer for 1,2 addition. 1,2 addition. But 1,4 addition will be the major product due to the conjugation, right? So what will happen in the 1,4 addition? What will happen? This is double bond, single bond, positive. Whenever you have double bond, single bond, positive, there is conjugation that you will have, right? So conjugation means this pi bond will shift here, right? And what you will have? And what you will have? You will have CH2, not CH2. Pi bond will shift here. This will be CH2, single bond, CH, double bond, CH, CH3. Right? CH will be because CH2 and this is 3. Now when pi bond will shift here, this will become positive, right? Because now we are taking electrons from this side, right? Now in the end, you will add Br negative to this place and answer will be CH2, Br, CH double bond, CH, CH3. So can you see we have done 1, 2, 3, 4. This is a product of 1,4 addition, right? This is the answer for 1,4 addition. Got it? So this is how conjugated alkenes, right? They will show 1, 2 and 1,4 addition. Got it everybody? Right? Okay. Now next is Diels-Alder reaction. Okay? Diels-Alder reaction. Diels-Alder reaction. Very simple. It is also very simple reaction. Chances are they can ask you. Right? Okay? Now, what is Diels-Alder reaction? So, a cyclic compound will be formed here with the help of two alkenes. Okay? So, just suppose that you have this alkene here and you have this alkene here, right? Now what will happen? This is the simplest version of Diels-Alder reaction. Now guys, let us see what will happen. You have this alkene and this alkene. Okay, yes. Guys, kindly focus here, right? Okay. Yeah, this is a very important chapter. You can see yourself, right? 2 to 3 questions easily can be asked from this one, right? Easily, right? Okay. Now, this and moreover, the same reactions will be repeated throughout the organic chemistry, right? That you will study in hydrocarbons, right? Okay. Even in the sequence reactions, like mostly they can confuse you by giving the starting product as some hydrocarbon, right? So you need to know this chapter as well. So this is your Diels-Alder reaction. How to do this? Let us see. This bond will shift here. This bond will, or you can just see this thing, like this bond will shift here. This bond will shift here. This bond will shift here. Right? Now, what will be formed? Here, I am drawing everything as same only. But I'll be drawing few bonds that are in the making. this bond is getting formed, right? This bond was already there. This bond is getting formed, right? And this bond is breaking. This bond is breaking, this bond is breaking, and this bond is getting formed. Now, in the end, what you will have this kind of answer. You will have this kind of answer. Blue bonds will be there, right? That means only this bond you will have in the answer. So this is called Diels-Alder reaction, okay? This is called Diels-Alder reaction, right? Now, one more way they can ask you this reaction, right? Okay, so how in JEE the questions can be asked, right? Okay, so you have this CH3, same funda you will apply here as well, right? It's not like the funda is different, the funda is same, hydroquinone, quinone, right? Double bond, O, O. Now, same thing will happen in this case also. Same thing will happen in this case also, right? Okay, you need to tell me the product. So how to make the product here, everyone? How to make the product? How to make the product, everybody? It should not be here, it should be double bond, double bond. So it will be two bonds here, one bond here, one bond here, right? Now the same funda we are going to apply here, same funda, and just delete this thing here. You will have these two things. What will happen? This bond will shift here, this bond will shift here, this bond will shift here, right? And what you will have in the product side? Firstly, the cyclic ring will be formed. A cyclic ring will be formed, right? A cyclic ring is formed. Now we can see that the new bonds are this one that I have attached here, this one that I have attached here. And now one new bond is this bond, right, that we are making, the pi bond. Rest of the things will be same. Here you will have double bond O, right? Not double bond, wait a minute. Here you will have, from this side you will have a benzene, not benzene, double bond here, and this is O, right? And here this is the bond that you have formed. Okay, so that is going to be the answer of Diels-Alder reaction here. Okay. Guys, at least reply, no. At least reply, bro. What happened? Why so silent? You want me to be violent? That's why you are silent? Guys, ऐसे तो I'll lose all the energy. Huh? It's only afternoon. You guys are not even speaking, nothing. Do I have to tell that daily? Should I record a video that should play in the starting, that only those students are allowed who can write, who have hands and they can write? Okay? Is it that difficult? Now I'll say I don't want to teach, then you will be like, okay ma'am, sorry ma'am, it's okay ma'am, really sorry ma'am. Huh? What is all this happening? Not interested in studying or interested in questions? Not even now any reply. So I'll take it as a recorded video or what? I can't teach for 3-4 hours in a recorded version, right? That will be too much irritating as on the part of a teacher. Chalo. Guys, should I just end this class? I don't want to give this dhamki daily and daily. I'll just end this today, right? So alkynes and alkenes, alkynes and aromatic hydrocarbons, you do it yourself. Okay? You guys do it yourself. I know you guys can do it yourself. So I have complete faith on you. So you guys can do this yourself, and that's it. Okay? Chalo. Okay, then I will end the class. If you are not like in that zone of studying, right? I'll just end this class. You guys do this yourself only. You have so many things, content already there. So you can do this yourself. Okay? Yes. I don't want to do this daily, yaar. I am not a stupid person here, standing here like a stupid person. Yesterday I took class till 11:30 and still I am today here, right? After this also I have my batch class. That's why I took the class. I could have deleted. I was like, okay, ma'am, you don't want to take, my team was asking me that, ma'am, you don't want to take class, because there is already batch class at 8:30 p.m., right, which is of 2.5 hours. So then I thought, okay, no, JEE means is very near, so I want students to have, full clarity on the concepts. That's why I am here, right? Otherwise, it's not my duty to be here. Trust me on that, right? It's not my duty. I am here because you guys requested for chemistry teacher here, right? Okay. So at least say something in the chat box. Those 17 students sitting here, if you're not talking, if you're not responding, then what's the use, guys? So I'll just end the class here, right? Okay. Chalo. I'll just end the class. Okay, guys. I joined late. What's happening, ma'am? Yeah, this is so daily it's happening. I think on the daily class, you watch my NEET class. Okay, you watch my NEET class yesterday, right? I am such a happy soul there, right? I don't have this kind of phase, and I'm always smiling, laughing, teaching my kids. You don't want to be my kids. You don't want to be Diksha ma'am's army, isn't it? I see this on the daily basis. I can't handle this much, this much boredom and this much, bilkul hi, silent zone in the chat box. And I don't want to do this daily, bro. I don't want to do this daily. I am no celebrity who is asking for any controversies here, and I want students not to respond, then I will make angry faces, then I'll get viral. Nothing like that, okay? So, nothing like that. So, if you guys are going to respond, I will teach. If you guys are not going to respond, the class will end like there only. I understand you can't type simultaneously because you are understanding something. But when I say, guys, are you able to understand? If that thing is not clear in your head, right, that if ma'am is asking this, it's been, I think I have taken 7-8 lectures on this channel, but if you still feel that I have to ask and request you, please beg you daily for your response, then I think I don't deserve this, and I'll not teach on this channel. Trust me on this. Trust me on this. Don't take any teacher for granted. And I don't want to be a rude person, right? Don't spoil my mood. Okay, you know what? What a person like me always run if she sees something which is making her mood spoil, which is making her day like totally ruined, right? So if you guys, right, do that to me, right, I come here, right, making all the notes, PPTs, selecting all the questions for you. Then after that, I see I have to beg literally like this, please respond. Then if you feel that ma'am will be here very happily standing there, ha ha ha, I'll teach. No, guys, I am not a robot, okay? I can't do this on daily basis. Now you have already spoiled my mood, yeah. Seriously. I don't know how many times, yeah, I have to do this. How many times, tell me. I was such a happy zone. I did yoga today. I was such in a happy zone. Okay, I'll teach firstly JEE aspirants and I'll teach in the batch. Very happy zone I was. So guys, that was about alkenes, right? So there are basically 3 kinds of alkenes that you have. And this is the reaction of conjugated. This is the reaction of Diels-Alder alkene. Okay, this is the Diels-Alder reaction basically, right? Now, next is we have alkynes. Now, what are basically alkynes? We know that it is having triple bond here, right? If you calculate the sp hybridization, so it will be 1 sigma, 1 sigma, 2 sigma means it is sp hybridized. Whenever something is sp hybridized, that is having a linear geometry. That is why alkyne is a linear compound. Okay, carbon-carbon triple bond. Now, let us do the preparation of alkynes. The first preparation method is from calcium carbide. Okay, first preparation method is from calcium carbide. As you can see here, ethyne is prepared by treating calcium carbide with water. right? That's a very, very important question, right? It has been asked in your JEE Advanced as well, JEE Means as well, right? So, ethyne is prepared. If you talk about ethyne, right? So, firstly, I'll tell you how to prepare ethyne, then I'll tell you how to prepare propyne. So, these two questions are basically in a sequence reaction. The first reaction will be with calcium or maybe with magnesium. You will have ethyne and propyne. Okay, so see this reaction. So firstly, so they are talking about this calcium carbide. How to prepare? Mostly they will give you starting product as calcium carbide only, but still if they ask you that how do you prepare this calcium carbide, that is with quicklime with carbon. When you react quicklime with carbon, you have the formation of calcium carbide. Now this calcium carbide on hydrolysis, directly it will form ethyne here. That is the first important thing for you, right? First important thing for you. Second is magnesium. This is also a very, very important reaction, okay? A very, very important reaction. That is magnesium carbide. It is going to prepare propyne. It is going to prepare propyne, and usually these two questions are only asked. First is ethyne, second is propyne, right? Okay, this difference is behavior of CaC2 and Mg2 side due to difference in their structure. That is why it is preparing, it is giving us ethyne and this is giving us propyne, right? This and this, that means if you take aluminium or if you take beryllium, they will have no formation of alkyne. Okay, but they will not ask you this thing, they will not ask you, but still you should have knowledge about it, that what if they give you this aluminium or beryllium, then you will have no formation of alkyne, right? But I'll tell you in the sequence, if they are going to prepare ethyne or propyne, they will give you directly this thing or this thing. From that the reaction sequence will start. Okay, today only we will see from the previous year questions as well, right? Second is from vicinal dihalides. Okay, so now we are going to talk about from vicinal dihalides. Dihalides, vicinal means when you have this thing, right? Here you have vicinal dihalides. Vicinal means firstly though on the adjacent carbons you have two halogens. Now dihalides, what do you mean by dihalides? Everyone, what do you mean by dihalides? Two halides are present here. Now from vicinal dihalides, how this thing is prepared. Let us see that, right? So this is your vicinal dihalide, right? What will happen? Firstly, in KOH, whenever you apply KOH here, in the presence of alcohol, what is going to happen here? Dehydrohalogenation, right? Okay, vicinal dihalides undergo dehydrohalogenation. Very important thing. Two important things are here. Firstly we are going to use KOH. Then we are going to use NaNH2. Both are bases only. But which is a stronger base? Which is a stronger base? KOH is a stronger base as compared, not KOH, not. NaNH2 is a stronger base as compared to KOH, right? So firstly we are using KOH here, KOH alcoholic, right? Let's suppose from this carbon, or let's suppose from this carbon, it is taking out Br and it is taking out H here, and this bond is shifted here, or from the opposite positions actually it is doing this, right? Okay, let us suppose that from this side it is taking out Br negative and it is taking out H positive from this side, and this bond is getting shifted here. Now this is the formation of alkenes, right? This is from the KOH alcoholic. Now, ma'am, why you not on the second step you have not used KOH alcoholic? Because now taking this dehydrohalogenation from alkene is even difficult, right? From alkene it was still easy, but from alkene it is difficult. That is the reason we are going to use a stronger base here, that is NaNH2, and now also Br negative will be eliminated, H positive will be eliminated, this bond will shift here, and hence you will have the formation of alkynes. Important thing is, first you will use KOH alcoholic, second you will use, in the second step you will use NaNH2 as the base, right? Okay, yes Divyansh, what is the doubt? Yes Divyansh, what is the doubt? Let me know in the chat box what is the doubt. Okay, now Second is chemical properties directly. Wait a minute. I'll myself write the other preparations here, right? So this is your second preparation. The third preparation is from geminal dihalides, right? If you talk about geminal dihalides, what will happen here, right? If you talk about geminal dihalides, what will happen? What do you mean by geminal? What do you mean by geminal? Firstly, so there are 4 bonds here. Geminal means on the same carbon you have X. On the same carbon you have X, right? When on the same carbon you have X, what will happen? Right? When on the same carbon you will have X, what will happen? Firstly, you are going to use KOH alcoholic here, right? Now, what will happen on the same carbon? So, what will happen? Firstly, X negative will be eliminated from this side. H positive will be eliminated, double bond will shift here. You will have the formation of RC double bond. This is H, this is X, and this is H. Wait a minute. So basically it will be R here, right? Hydrogen is there. So H and this is R, right? R can be anything, it can be hydrogen also, right? Okay. Now, again, as what we did here, we are using the stronger base here because now we have alkene. It is difficult to take out hydrogen and halogen from this one. So we are using a stronger base, that is NaNH2. Again, the same thing will happen. X negative will be eliminated from this side. H will eliminate from this side. Double bond will shift here. And hence you will have the formation of C. This is R, triple bond. This is C. And this is H. This is the alkyne that will be formed here. Okay, this is the alkyne that will be formed here. Got it, everybody? Okay. Okay. Yes. Next preparation is from tetrahaloalkene. Tetrahaloalkene. Now tetrahalo definitely means 4 halogens, right? Okay. Tetrahalo, what do you mean by tetra? Tetra means 4. Now we have 4 halogens here, right? We'll have 4 halogens. These all reactions are somewhat similar to alkenes also, right? So tetrahalo means 2 carbons here. You have 2 halogens, 1x here, 1x here, 1x here, 1x here. This is H. Let's suppose this is R, right? Now guys, let us see what we are going to do. We are going to use zinc, right? Basically 2 molecules of zinc will be used here. In the first molecule, dehalogenation will occur here, right? Halogen will be eliminated from this side, right? Firstly, this halogen will be eliminated, then this halogen will be eliminated, then you will have minus 2x2, right? And you will have the formation of RC triple bond CH. Right, you will have the formation of RC triple bond CH. Okay, got it? Yes. Janvi, no, then you don't need to study this. If you are preparing for JEE, right, this I have completed there also, right? So then you don't need to see this. But if you are preparing for JEE, then when I'll start the previous year questions of JEE, then you can watch this. Because those questions are not, I have not done that before, right? Okay, understood? Yes, guys. Next is Kolb's electrolysis. 5th one is Kolb's electrolysis. Kolb's, now this though we have done before also. Kolb's electrolysis, isn't it? We have done this before. How we have done this before? Kolb's electrolysis. I told you that you have RC double bond already. This is R dash. This is C, COONA. This is also COONA. Now using Kolb's electrolysis here, right? Kolb's electrolysis, what will happen? This bond, right? This will be eliminated, and here you will have the formation of R, you will have the formation of one double bond here. This is RC, one more bond, and this is R dash. Okay, understood? Understood everybody? So this thing will be formed, right? This thing will be formed. Got it, yeah? Everyone? Chalo. Right? Next we have, right? Next we have very important, that is from higher alkynes. From higher alkynes. Let us see from higher alkynes how to prepare this. Right? From higher alkynes. From, lower alkynes, yes, lower alkynes. From lower alkynes to prepare higher alkynes. This is using Grignard reagent. Okay. So let us see how to do this reaction. This full mechanism is important for you. So I'm just going to write down the full mechanism here. Now see, guys, one thing very important to note down, one property of alkyne is very important for you, that alkyne, because of these triple bonds, we know that it is sp hybridized. Because this is sp hybridized, no, this hydrogen is very acidic in nature, right? Because this hydrogen is very acidic in nature, that is the reason, okay, that is the reason it will show these kind of reactions, right, with the Grignard reagent. I told you one property of Grignard reagent, whenever we did Grignard reagent, the property was, do you remember that property of Grignard reagent? That property was that Grignard reagent is very reactive towards moisture or any proton donor. So basically this alkyne is a proton donor species. That is why you will have positive here, negative here, just a way to understand things, right? This will be partially positive, this is partially negative, this is partially negative, this is partially positive, right? Okay, so what thing will happen? This H will replace MgX here, right? This H will replace MgX here, and it will be HC triple bond C MgX, right? And here you will have minus RH, that will be minus. Okay, wait a second. Yes. This is a Grignard reagent, this is minus Rx. Now, till here, so the property of Grignard reagent that we were using is that Grignard reagent is very reactive with the proton, right, with any proton source, right? Now, this is your new Grignard reagent. This whole is, this full thing is, this full part is R. This is RMgX now, right? Okay, this is RMgX now. Now this you are reacting, let's suppose you are reacting this with CH4, right? Okay, you are reacting this with CH4. Now what will happen? Now what will happen? This Grignard reagent, this is the R part, this is HC triple bond C, this is CH3, it will attack here, right? Because this will be partially negative, this will be partially positive. So this H is going to get attached to the MgX here, and the CH3 will get attached here, right? And hence you will have CH3 is attached here, so it will be MgXH. This will be subtracted from here, right? Okay. Okay, everybody, right? Wait a minute, something is wrong here. Wait a minute, something is wrong here. Here we had RMgX, this is MgX, this is H, proton is subtracted here, this will get attached here, so this will be minus RH. This will be minus RH. Here, if after this you add, wait a minute, if after this you add CH3X, or anything. Let's suppose you are adding R dash X. I am supposing you are adding R dash X. Okay. To make a generalized answer, if you are adding R dash X, what will happen? This is partially negative, this is partially positive, right? Now this is partially positive, this is partially negative. Now it will replace this MgX here. So it will be HC triple bond C. This will replace this X positive positive. So it will replace this R and it will be X and X here. It will be MgX2. This will be the answer. Okay. This will be the answer. Okay. Yes. So here we are subtracting. Basically what you need to see, the positive negative you need to see here. Right. Because it is a proton acceptor. It will accept the proton, right, with RH, right, and some hydrocarbon alkene will be subtracted here. This will get attached here. Now again we have this partially negative, partially positive. We are adding, suppose, any alkyl halide here. This is partially positive, this is partially negative. So this positive part will get attached here, will replace this, and hence you will have the formation of this higher alkyne. Okay, you will have the formation of this higher alkyne. So basically these are known as step-up reactions. Okay, these are known as step-up reactions. So suppose they are giving you any, let's suppose they are giving you some molecule here, this is B, right? This molecule, for example, is having 1 carbon less, this alkyne is having 1 carbon more. So in that case, if they ask you the reagent will be Grignard reagents, then you add any alkyl halide, that will be the reagent, right? Okay, so these kind of reactions are very useful in your step-up reactions. Okay? Okay, guys. Now, with the same thing, one more kind of step-up reaction. Because I told you that Grignard, you should have a proton donor. This is a proton donor. If there is anything which is a proton acceptor, for example, NaNH2, it is a base. Now a base is a proton acceptor, right? So a base will accept the proton here. This is positive, this is negative. Again, same thing will happen. This is CH triple bond C. This is Na, right? Again, same thing will happen. This is positive, this is negative. Now you are going to add again R dash X here. This is negative, this is positive. This is positive. So positive will get replaced here. So this is CH triple bond C R dash, right? So any proton acceptor source can be there, like you had RMgX, like you have NaNH2, any proton source acceptor, not source, any proton acceptor you can use here, right? Okay. Okay, everybody. Okay, everybody. Now that was the seventh method. Seventh method is from haloform. How many of you remember haloform? How this reaction can be given to you? Again, in a sequence reaction they can give you. For example, they have given you with ketone or with aldehyde, where it is showing iodoform test or haloform test. You have prepared CHX3. This is haloform. Now from this haloform, using silver, right, directly you will form the alkyne. Okay? Yes, directly you will form the alkyne. So this is just example, CHX, right? So if I am saying you have H here, this will be H. If I am saying haloform should have 3 halogens. Right, this H can also be any R here. You can write H also, R also, depending upon the question. Now, just like zinc, silver is also a very important, in the formation of alkyne. We have used 3 kind of things. One is sodium, then zinc, then silver. Right, these 3 things we have used. This was used in Wood's reaction. This also we have used in the formation of alkenes and alkenes also, alkynes also. Now silver we are using, right? So don't get confused in these things. Here what will happen? It will take all these 3 halogens from here two molecules will be attached. You will have RC, right? And there also you will C and R, and here you will have the formation of these three bonds will get attached to each other. Basically, two molecules of haloform you will use here in the presence of silver, and you will have the formation of alkyne. Like double number of alkyne will be formed. Okay, double number of alkyne will be formed here. Right? Okay. Very good, very good, very good, very good. That was your haloform. Very good. Now let us see the chemical properties of alkynes. What are the chemical properties of alkynes, guys? Alkynes are very reactive to pi bonds, right? This was also one of the chemical properties only. This is also the chemical properties of alkynes only. Like how alkynes are proton donor, and that's why they give you higher alkynes with Grignard reagent, right? So now let us see different chemical properties of alkynes. First is alkynes are very reactive due to pi bonds, because they have pi bonds, that's why loosely bound pi bonds, that's why they are very reactive, right? That's why they show all the kinds of reactions here. Addition reaction, acidic character. Acidic character means to donate the H positive, right? So then you have ozonolysis, then you have polymerization, all kind of reactions it will show you, right? So one by one, firstly, so we will see the addition reactions here. Okay, so firstly we will see the addition reactions here. Okay, guys. Definitely Birch reduction in benzene is definitely important for JEE. Definitely it is important. Okay. Now, let us see the chemical properties. Wait a second. Addition reactions. Now, firstly we are going to do. Alkynes contain triple bond. This is all that katha that I told you. Right. So now let us see addition of hydrogens, right? So first is addition of hydrogens. Have we done this reaction? Have we done this reaction, addition of hydrogens, right? Sabatier-Sanderson reaction, if you remember, in that we did a triple bond. You add nickel and hydrogen, right? Then you will get the answer, right? And I also told you alkynes are preferred as compared to alkenes. Alkynes are preferred as compared to alkenes, right? In Sabatier-Sanderson reaction with nickel, the temperature was around 200 to 300 degree. With alkyne, we prefer 300 degrees Celsius, right? Okay, so this is what they have written here, that Sabatier-Sanderson reaction, right? So we will have high temperature around 200 to 300 degrees Celsius. From alkyne, firstly you will have the formation of alkene, then you will have the formation of alkane. That is called Sabatier-Sanderson reaction. Okay. In detail, we have covered the hydrogenation part in alkene itself. I taught you everything that they can ask you, right? Next is addition of hydrogenation in the presence of Lindlar's catalyst. Now, guys, there are two kind of more hydrogens from which is actually where we are not doing hydrogenation to very high extent. We are stopping it at alkene point. So there are two kind of methods. First is with Lindlar's catalyst. Then we have with the Birch reduction, that is NaNH3 liquid ammonia, right? So with Lindlar's catalyst, you will have the formation of cis alkene, and with the Birch reduction, you will have the formation of trans alkene, right? This is important for you to note down, right? Because this is also asked to you. This is frequently asked in JEE, right? Very frequently. This is also very frequently asked. Lindlar's catalyst is basically hydrogenation only, but it is poisoned by sulfur with BaSO4, CaCO3, anything, right? So it is poisoned by the sulfur, right? Next we have the mechanism. Now the mechanism, let's go through that, but it's not very important if I talk about your competitive exams, right? But you can just go through this once, right? This is your alkyne part, right? This pi bond will be taken here, right? This pi, see what will happen firstly, though it's a free radical mechanism. So what will happen? Sodium and liquid ammonia. What will happen? Here with this liquid ammonia, you will have one electron, right? This we have studied in S block, I feel, right? S block when it was there in the syllabus, right? So liquid ammonia has one electron, right? That is the solvated electrons, right? So with this liquid ammonia, the solvated electrons will be pushed here to the sodium, and you will have the formation of Na positive here and this electron, right? Okay, now this is your alkyne. One electron, one pi bond will jump here. This electron is going to attack here. This electron that you got from here, this is going to attack here. You will have the formation of one free radical here, right? And this is your negative charge. Now this is the base. What a base does? What a base does? Now base is going to take out the proton from this side, right? Okay. So let me see. Yes. So acha. Wait a minute. Here so they are adding this, no? Because you had no proton here. You have no proton. So they will definitely add the proton only, right? Because you don't have any proton here, right? So what will happen here? Now things will be different, right? Now this NH3 will not act as a base, right? Rather this hydrogen, it will donate to this side, because here you can't see any proton, right? In fact, this is electron rich only, right? So that is why H positive will be attached here, because this is already negative. H positive will be attached. One more electron will be donated here. You will have a negative here. Again, then H positive will be attached here, and hence you will have the formation of trans alkene. Okay, understood? So basically this NH3, right, ammonia is not going to, basically in this ammonia you will have the electron, and this ammonia usually it is a base, but here it is not acting like one, because for to act like base it should have a proton to accept something, right, which it does not have here. Now let us see for next one is addition of hydrogen. Wait a minute, this is with the B2H6, that is hydroboration, right? So how hydroboration work and how you are going to add hydrogen here, right? Alkynes is first reacted with the diborane followed by acidic hydrolysis, right? Hydroboration, after that you have acidic hydrolysis. So see, hydroboration part is same as alkene only, right? The same that we did in alkene, right? So here what will happen? You will have this pi bond here. This pi bond will get break. Just like in alkene case, we know that this pi bond used to break, and after that you had the following reaction. So here what will happen? This pi bond will get break, right? This is BH3. We know that borane is basically electron deficient only, so it will attack over there on the pi cloud here, right? So this being electron deficient, it will try to attack on the pi cloud here, and what will happen? Electrons will shift on one position, either on this or on this position. And to which position electron are shifted? To that carbon you will have one extra bond. Okay, so just taking an example that electrons have shifted to this position, then to this carbon you have the attachment of this borane, right? To this carbon you had the attachment of this borane. Yes, just say this is methyl, this is carbon. Because of this BH3, you will have one hydrogen here and one B here, right? So this B will attach to this particular carbon, and hydrogen will be added here, and hydrogen will be added here. Now we know that you have BH3, right? So in this hydrogen, right, replace this hydrogen with 3 molecules of this side. 3 molecules of this side, that is MEC double bond C, Me, right? This kind of molecule. So you will just replace this with 3 molecules of carbon. This is that carbon where boron has attacked, right? Here you have one pi bond and one sigma bond, one carbon, one methyl here, and one more methyl to this side, right? This is how BH3 is converted into this compound, right? It is same as hydroboration only, right? After that, instead of oxidation, we are doing acidic hydrolysis, adding acid, right, and doing the hydrolysis. What will happen? You will have the formation of cis butene here. Basically this this whole thing will break, right, and you will have the formation of 3 molecules that are having double bond here, and Me and Me will be on the same side. Here you will have hydrogen, here you will have hydrogen, right? So cis either upwards or downwards, it will be on the same side. So cis butene is formed in this case, right? Okay, got it? So basically it is same like hydroboration, but the oxidation part is not here, right? Here we have the acidification part, right? That means after that we are going to do the acidification here. If we do the hydrolysis oxidation part, then here you will have the attachment of OH, right? We are not doing that, right? Okay, got it? Like, okay. Okay, now next is addition of hydrogen, right? Also, this we have done. This is due to test for unsaturation. Now let us see when you are adding Br2 here, right? This should be Br2, right? Reddish orange color of bromine, right? This also we have done in alkenes as well. That bromine vapors have reddish brown color whenever you add this to any unsaturated compound, right? That will be converted into the alkene. Like if you have alkene, right, then you will have the addition of Br and Br, and hence you will have the formation of dihalogen compound. But if you have triple bond, then what will happen? 4 Br will be attached here. That is why tetra compound will be formed here, right? But the color of bromine vapors will not be there. They will decolorize. That is why we can visibly see that, and that is why it is called the test of unsaturation, right? Next is addition of hydrogen halides, right? Now this is, I would say, a important reaction. Till now though we were doing like okay reactions only. Now this is an important reaction, right? Because in alkynes we are adding HX, right? Same rule will be applied here, Markovnikov, anti-Markovnikov, everything is going to be same only. Just give me a second. Okay. Okay, you need to see the name of the channel, Dhruv. Okay, so this is Markovnikov and anti-Markovnikov. Both the rules will be applied here, right? So if you see this reaction, right? Similarly, when you have HX, apply Markovnikov rule here. So negative part to less number of hydrogen, that means here negative part will be attached, here hydrogen will be attached, and this will be the answer. Again you are adding HX here, then again this is negative positive, negative part will attach to the less number of hydrogen. That means this hydrogen, here you have less number of hydrogen, so negative part will be attached here, positive will be attached here, and you will have the formation of geminal dihalides always and always. So they can ask you directly that when you add halogen halide in alkynes, do you have the formation of vicinal or geminal dihalide? So you have the formation of geminal dihalides. Always you will have the formation of geminal dihalides only, right? Because always you will have on the less number of hydrogen will be here only, na? So if you talk about here, you will have, once you have less number of hydrogen on this side, then you are adding X here, then again less number of carbon will be on that carbon only. So it will always form geminal only, right? Always it is going to form geminal only, right? Okay, so now the mechanism is also same, right? It is going to have your halonium ion in between, right? And because of this, this is an anti-addition. This is anti-addition, right? But they will not ask alkyne. In alkynes, they focus more on the reactions rather than anti and syn addition, right? So the reaction takes place. Now a lot of reactions, only simple reactions they will ask you from alkynes, okay? That's why every single reaction is important for you, right? Okay, so this is the mechanism. A cyclic intermediate will be formed. That is why the attack is anti-attack. Okay, next is in presence of peroxide, it will follow anti-Markovnikov rule. Anti-Markovnikov rule. So what will happen in the presence of peroxide? Negative part is attached to more number of hydrogens. That means this side negative part will be attached, this side H will be attached. Now what you will see, after this you will have one hydrogen here, you will have one hydrogen here only. But now the question is, ma'am, where negative part will be attached? Because both are having same number of hydrogens. So negative part will again attach to that carbon only where it was before, because originally the more number of hydrogens are present here, right? So negative part will be attached here only, even in the first place, even in the second place. So here also you will have the geminal dihalide, but that is on the terminal position, right? So negative part on the more number of hydrogen, right? More number of hydrogen, right? Okay, so this is the mechanism of with peroxide, right? With peroxide you have this Br, a free radical, then it will just go get homolytic cleavage for this pi bond, carbon carbon pi bond, then again you will generate one more free radical, then again this free radical will attack here, right? All of this thing will happen. You don't need to see the mechanism here. Just remember that in peroxide linkage, whenever you see any peroxide linkage like H2O2 and hydrogen peroxide, or you can see any peroxide linkage you see, in that case you will have the formation of anti-Markovnikov rule, product will be formed, right? Okay, so next is addition of water. Now this is a very important reaction, very important reaction, right? Okay, this is one of the most important reactions of alkynes, right? Why? Because it follows two things, right? First is there is no simple acidic hydration that we are doing here, rather than we are doing the hydration in presence of Hg2 positive ions, right? So in presence of Hg2 positive ions, that is we are doing the hydration, 1% Hg2 positive ions. We are also using H2SO4 here, right? So now I am going to take one example here, right? I am going to take one example here. Wait a minute. The example is if you have CH3 triple bond CH, CH3 C triple bond CH. Now this question is interesting, right? Now what you will do, you will add H positive and OH negative, that means negative and positive parts you will join. Firstly, pi electrons either will jump here or they will jump here. Two cases can happen. I am saying that pi electrons will jump on this side, not on this side, on the opposite side. Pi electrons will jump on this side. Reason being, because after this you will have the positive negative, as if the electrons are jumping on that side, you have two bonds here. Electrons are jumping on this side, so this is negative, this is positive. So positive on this is more stable or on this is more stable? Definitely positive here is more stable because of the inductive effect of CH3, right? So that is why this is done, like positive is on this side. Now to which you have negative, just attach hydrogen, right? So that means you will have CH2 here, right? You will have CH2 here, and to this positive just attach OH negative here. Attach OH negative here. Now what you have? This is the formation of enol, right? So we know that there is a tautomerism, that is keto-enol tautomerism, right? Now here what will happen? Tautomerism will occur here, right? Tautomerism, and because of the tautomerism, you will have the product as, this is 1, this is 2. Let's suppose this is 1, this is 2, this is 3, right? So what we are going to do now? Tautomerism is very simple. Just break the bond of 1 and 2. I'm just going to write the same thing here. Then I'll teach you how to do that. This is CH3, this is COH double bond CH2, right? So I am saying break the bond of 1 and 2. Just break this bond. Attach double bond O here. Attach this bond here, right? Break the bond of 1 and 2. Attach it on 2 and 3. Then this hydrogen is internally shifted to the first position. That means this hydrogen is internally shifted to the first position. That means you will have CH3 here. Now you have the formation of ketone. Here. That is why, because of this step, this reaction becomes very important for you, right? Okay guys, thank you. Got it? Acetone product will be formed. This step is important for you. It's a very simple reaction, but it is like asked, like frequently these questions are asked to you, right? Then you have ozonolysis. Now, do you remember I told you a trick of ozonolysis, right? When we were doing alkenes, what was the trick? The trick was break the double bond, attach double bond O. Same thing we are going to do here, but remember one thing, that here you have triple bond. So only two bonds we can break, right? When we had alkene, we used to break this bond and we used to attach double bond O here, double bond O here. Usually in ozonolysis, they will ask you the question from alkenes, okay? So I am just telling you what in previous year questions what they are asking you, right? Usually they will ask you question from alkenes, but you should also know with alkynes what you have to do, right? With alkynes, you have this triple bond, you will break this bond and attach double bond O here, like this, okay? So now, for example, you had this thing, this is CH, triple bond CH. Now we know that a hut will be formed, ozonide will be formed here, right? This you should know, because sometimes they can ask you, they can just erase this thing, they can give you this is A. In the option they can ask you what is this A? What is this A? Then for those kind of questions you should know the mechanism at least, right? Okay, you should at least go through the mechanism once, right? Now this ozonide will be formed here. We know that two bonds will break here. This carbon, this bond will stay as it is, right? This bond and this two bonds will break, one oxygen here, two oxygen here, right? After that, definitely this bond will break, this bond will break, this bond will break, and you will have the formation of double bond O here. That is a full-fledged method. But directly what you have to do, you have a triple bond, break two bonds here, then attach double bond O here, right? Same thing we are going to do. The same thing that we did. You had one alkyne here, break these two bonds, attach double bond O. You have the formation of glyoxyl here, right? Okay, got it? Now next is what if after the glyoxyl, do you remember I told you there is one oxidative and one reductive ozonolysis? Do you remember what I told you? In a reductive, so you just have to break the double bond, attach double bond O. That is the thing for reductive ozonolysis. The same thing is happening in alkyne also. That's why once you have, thoroughly gone through in detail, you have done alkenes, then alkynes become very easy for you, right? Now, that's why now in the oxidative ozonolysis, once you have double bond O, then also there is one more step, then replace hydrogen with oxygen, OH. You replace the carbonyl hydrogen with OH. That will be the answer. Now, for example, you have this as the answer. After this, if there is a reductive, if you do the reduction, see till here you have reductive ozonolysis. Now after this, if they are asking you answer for oxidative ozonolysis, what you will do? What you will do, everyone? Firstly, this bond is going to break, right? This bond you will break, this will be HC double bond O. This bond will break and here you will attach OH, right? Then here also this bond will break and you will attach OH here. So it will be H2CO3 in both the cases, right? Okay, yes. So it will be H2CO3 that will give rise to CO2 here, right? Okay, wait a minute, let me show you that with more example. Just give me a minute. Let me take a very, very interesting example here. So I'm going to take one example here to show you what exactly I'm telling you, right? Because this way it will be difficult for you to understand, right? Chalo. Now I'm taking one example for you, showing to you the reductive and oxidative both those ozonolysis. So the example that I am taking is CH3C triple bond CH, right? We are doing the ozonolysis here, right? Once you add ozonolysis, then what will happen here? Break this pi bond, break this two pi bonds and attach double bond O, right? Break a double bond, attach double bond O, so it will be CH3C, one bond will stay as it is, double bond O will be attached. Now this is the answer for reductive ozonolysis. Now if you have added zinc here, then this will be the answer. But if they have given you oxidative ozonolysis, they have given you that you are adding not this, but you are adding O3 with H2O2, right? That this is what you are doing. So this is oxidative ozonolysis. Now you will break this bond as well, and you will attach OH and OH on both sides, right? So what will be the answer? What will be the answer? Break this bond, it will be CH3, C double bond O, OH, plus it will be OH, C double bond O, H. So it will be CH3, COOH plus H2CO3, okay, plus H2CO3, okay. Having a molecule mass of 42, the alkene is. Akshay, control your emotions, okay. Acha guys, tell me, is that clear or not? Ozonolysis, right? Here they can also give you Ag2O, or they can also give you Me2S, right? If they give you H2O2, Ag2O, Me2S. Now remember Me2S, right? This, when we were talking about the oxidation of alkenes, this was in the reductive ozonolysis. But when we are talking about the oxidation of alkynes, ozonolysis of alkynes, this is in the oxidative ozonolysis. So this part is important for you, right? So I'm just going to highlight this here. I'm just going to highlight this thing here, okay? Okay, understood? Definitely, yes, Tohiro. There is Vedantu NEET English, right? So you can also watch my lectures there. Right, guys, got it or not? Everybody. Now some reactions. Now let us see how many. Okay, now few reactions we are left with. So I'm going to teach you those reactions as well. Right? So let us study a few more reactions here. First is, have we done a reaction with hydroboration? We have done. Addition of H2X, have we done the addition of H2X, guys? Have we done the addition of H2X or not? Addition of H2X. Addition of HOX. Now, in the same way that we will talk about, that we have CH3, C triple bond CH. You are adding HOX here, right? HOX. This is negative, this is positive, right? So what is going to happen here? Everybody, what is going to happen here? Now, again with the Markovnikov addition, right, negative part will be attached to less number of carbons, right? So this is CH3, C double bond C, H, negative part is attached to less number of carbon. Again, I am just writing here Markovnikov addition, right? Simple reaction, it is very simple reaction. Negative part is attached to less number is present here. So you will have OH here and you will have X attached here, right? Now can you tell me one thing, that this part, what I call this part? What I call this part? This is enol, right? So this is enol. Now can I write here, if this is enol, then there can be tautomerism. right? Can you draw the result of tautomerism, everyone? Can you draw the result of tautomerism, everyone? The result of tautomerism. The result of tautomerism. Everyone, the result of tautomerism. Tautomerism, acha, we had OH here, enol here, double bond will be shifted here, H will go to this side, okay? So firstly, I am drawing the result for tautomerism. Two answers will be available to you here, right? So firstly, let us do tautomerism, right? Firstly, let us do the tautomerism. So with tautomerism, what will be the answer? Everyone, with tautomerism, what will be the answer? With tautomerism, we know that this is CH3, this is C, this double bond will be shifted here, this is 1, this is 2, this is 3, double bond will be shifted here, you will have double bond O, hydrogen will be shifted here, you will have CH2X. This is formed as your one product. There are actually two products, okay? This is the first product that you can get. One more thing can happen here. This is the first thing that can happen. One more thing can happen here. That is, if one more molecule of HOX is added, one more, this is negative, this is positive, one more molecule is added, then what will happen? This is CH3, CH3, C, C, H, right? Now, again, your OH is added on the same side where you have less number of hydrogens, that means on this side. So OH is again added here and X was present here, now X is also added here. Two things are happening. If you have one molecule, you can have this answer. If they have given you two molecules, 2 units, then what will happen? Again, this pi bond will break and you will have this as the answer. Now guys, on one carbon, 2 OH are not stable at all, right? On one carbon, 2 OH are not stable at all. So what will happen in this case? You will have H, right? So what will happen? OH negative will leave, H positive will leave, the bond will shift here. And you will have the formation of, CH3, C, double bond O, CHX2. This is the second product that can be formed here. This is the second product that can be formed here. That means the name is also very important. This is alpha haloketone, or this is alpha, but on alpha position you have two halogens. Alpha dihaloketone. Two things can be formed here. Understood, guys? Two things can be formed here. This is, it's not a mechanism, guys. This is not even a mechanism, okay? This so you need to solve it like this only, right? I am not teaching you mechanism of those reactions which are not very important for you, but this is not even the mechanism, right? This is actually the step in which you will get the answer, right? If you want to cram, you will get the wrong answer, right? Because directly you cannot answer something here. You have to go through this full process, only then you will be able to answer. Otherwise, there are chances that you might do any mistake, right? So it's a very simple thing. Apply Markovnikov rule here, then tautomerism. Apply Markovnikov rule here as well. Then eliminate water and you will get the answer. Okay? Understood? Yes, everyone. For whole organic, do I need to remember the mechanism? See, you don't need to remember the full mechanism. Let's be very honest here, right? So, if you see, you should know how to apply that. You should know firstly the reagent, the reactant and the product, right? And the conditions and the intermediate as well, right? So, these 3-4 conditions you need to remember for a reaction. There are few reactions in which mechanisms are important, like Gabriel phthalimide, right? Hoffman bromamide, carbylamine. Here you need to Cole's reaction, Riemer-Tiemer, Dow's process. So these are some of the reactions where full mechanism you need to know, right? Just in case they ask you anything related to the intermediate. But usually, if you know what is an intermediate, carbocation, carbanion, what is the process, then you will be able to answer. Okay. I would advise you, abhi to just go through the lectures on YouTube and then solve as many questions as possible, right? Okay, instead of learning the mechanism firstly, go through the way I am telling you. After that, go through the questions, you will be able to answer them, right? Okay. Huh. Next, we are left with one more question, that is addition of HX. So we have done, right? Addition of HX have we done? We have done addition of HX, we have done addition of H2X as well, addition of H2 as well, addition of X2 as well, hydroboration also we have done, addition of water also we have done, then HCN addition. Okay, very small reactions we are left with. HCN addition, this can be asked in any sequence reaction, any sequence. For example, you have CH3, C triple bond CH. Here BaCN twice. Now this will be added here, right? This will be added here. You will have, right? Wait, HCN though I forgot to write. So this is H positive. Wait a minute. This is H positive and this is Cn negative, right? So again, add through Markovnikov addition, right? Okay. Negative part to less number of hydrogens. No, it will be anti-Markovnikov. Yes. It will be, the difference is it will be anti-Markovnikov addition. Okay. Here you had Markovnikov addition. Here also you had Markovnikov addition. Right? Here also I am going to write it here, Markovnikov addition. Right? Here also you had Markovnikov addition. Right? Here also you had Markovnikov addition. But in HCN you are going to have anti-Markovnikov addition. That means negative part on more number of hydrogens. So it is CH3, C, double bond, pi bond will break, C and H. Here negative part will be on more number of hydrogen. Right? So anti-Markovnikov rule will be applied here. Okay? Anti-Markovnikov rule will be applied here. Right, guys? Okay. Chalo. Now I think we have done these reactions. Now we are left with the oxidation. Let me just write it somewhere here, right? And this somewhere here, right? And here I am writing oxidation reactions, okay? Oxidation, because we have done ozonolysis, but simple oxidation. Simple oxidation, if they ask you with KMNO4K2Cr2O7, then what we have to do, right? Okay. Okay, do you remember this one? CnH2n minus 2 plus 3n minus 1 by 2 O2. Then you have n minus 1 CO2 plus H2, NH2O is formed, right? This I told you with the alkanes also, alkynes also, alkenes also, that what you will do. In case of alkanes, why I always teach this like with all the things, that is alkanes and alkenes, because here you have plus 2, so it will be Cn plus 1 by 2 O2 give rise to n plus 1 CO2 plus NH2O, right? So it is plus 2, so plus 1, it is minus 2, so minus 1, minus 1. This is what I wanted to tell you. This is CnH2n, because here you have plus 0, so here also you will not add anything. 3n plus 2, this also you will not add anything. So answer will be this one, right? Okay. Yes, everyone. Yes, everyone. Everyone. Array. This is CO2 and this is H2. I always get confusing this. So this is this is H2O, sorry. This is H2O, 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 and this is CO2, CO2, CO2. Arey, wait a minute. N, 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 N. H is 2N minus 2, 2N minus 2, 2, 2, 2N minus 2. Yes. Okay. Yes, this is balanced. Right? Just have to check also. Just if you're confused between that, you can just check with the help of this carbon and this hydrogen. Right? If that is same, then everything else will be same. Right? Okay. If you're applying this particular method. Right? Next is, this is so general, this will be asked like 0.111% that they will ask you this, right? So don't get too much burden of this one, but it's easy, so that's why I taught you there. Now let us see two things. Let us see two things. First is with cold diluted KMNO4. See, always remember, cold is having less oxidation, hot and concentrated will have more oxidation power, right? So cold and diluted will have less oxidation power. So let's write it here. Okay, so I'm just writing this thing, C triple bond CH, should be CH, and this is also CH. Now this is less oxidation you are doing. So in less oxidation, usually the answer will be of your ozone or reductive ozonolysis. That means this pi bond is going to break, two pi bonds will break here, or you can even write it like this. Okay, CH triple bond CH, right? With less oxidation, this pi bond will break and you will have the formation of double bond O, HC double bond OH. I told you that usually, it's not always, right? Don't like make a thappa there, okay, always this will happen, right? Usually, this answer is same as reductive ozonolysis, right? Because both are having less oxidation power, right? Okay. Okay, now this is for cold diluted KMNO4. This is same as reductive ozonolysis that I told you in alkenes as well, right? Now you are further doing the oxidation. What I told you in oxidative ozonolysis, you will do the same thing here. That means you are going to break this bond and you are going to attach OH here. So it is C double bond OH, this is H. Similarly here it is H, this is OH, C double bond O, this is H. That means HCOH you will get, right? So this is same as we did for oxidative ozonolysis, right? This is same as oxidative ozonolysis, right? Okay guys. Okay guys. Acha. Now, if I am saying that I am using hot concentrated KMNO4 or K2Cr27. Now, K2Cr27 is a stronger oxidizing agent. That is why whenever you see K2Cr27, it will give the answer as oxidative ozonolysis only, right? So, here I am saying that what if you are using hot concentrated KMNO4 or K2Cr2O7, then directly you will get the answer that you will get for oxidative ozonolysis. Okay? Okay guys? Not for advanced. Advanced, so you will do that with the help of problems. Okay? Got it? What I told you, it is same as oxidative reductive. In reductive ozonolysis, break two bonds, attach double bond O. In oxidative, to that product only break the single bond, also attach OH on each side. This is for alkynes, right? Now, if you are doing cold diluted KMnO4, that will give the answer as reductive ozonolysis only, right? Further, you are doing the oxidation, then you will get the answer as oxidative ozonolysis. If you are directly adding hot concentrated KMnO4, you will get the answer for oxidative ozonolysis only. Got it? Okay. Simple way of relating these two things. Okay, guys. Now, after this, so we did the same thing in oxidative reductive ozonolysis. Same thing we did here, right? Same thing we did here. Now, last one is oxidation with selenium oxide. Now here the oxidation will stop at certain point, okay? Here the oxidation will stop. So directly you should know the answer. Here the oxidation will stop. The bond will break. Oxidation will stop at this point. Right? It will stop at not COH, but it will form directly CHO on both sides. Right? Okay. So that will be the answer here. Got it, guys? Chalo. Now we are just left with few reactions here, acidity and aromatization, then aromatic compounds. After that, we'll start with the questions, okay? Okay. Now, let us see acidic character of alkynes. Acidic character of alkynes, as I told you, that alkynes are a very good source of proton donation, right? They are very good source of donating the proton. So they will try to donate this proton because of sp hybridization, right? They are very electronegative, that is the reason. Now, if you are saying that you are going to react this with sodium in presence of NH3, this sodium will be replaced by the hydrogen here. You will get this as the answer, right? Okay, if you are saying that NaNH2, again this NH positive, just remember the positive side will be replaced here. Take it as an acid. Whenever you had CH3COOH, with sodium, it used to replace this H with Na. The same thing we are doing, this H is getting replaced with Na. If you are replacing this with, if this CH3COH is getting reacted with NaNH2, any base, so what will happen? This H will be replaced by again Na. So here this H is replaced by this Na again, right? So same thing is we are going to do, right? Okay. Now, again, what we are doing, the reaction utilization preparing of higher alkene. This I told you how we are going to do this. Everyone, this we have already seen. Haven't we? This we already have seen this. This I told you this reaction before also. That suppose you have any proton donor, right? Not a proton acceptor. Now this is a base, this is a proton acceptor. It will accept the proton here. So when it will accept the proton, here you will have the formation of Na because it will be maybe NaNH3, right? So here you will have the formation of Na positive. Now after this, it should not look like this. It should be it should be Rx here, right? This should be NaNH3. Only then this will be replaced. Okay. Let me write it here. It should be NaNH2. Then this positive negative, this will be replaced by H here, right? And then you have, when you add R dash X, this R dash will be replaced by this Na here, and you will have the formation of higher alkynes. This is step up reaction that we have already seen today, right? Okay, that is the application of acidic character. Now they are saying that triply bond carbon are acidic, but not all the hydrogen atoms of alkynes. Only those hydrogen atoms, this is your triple bond. Next to it, that the carbon that you have, this hydrogen is your acidic. That means alpha hydrogen is acidic in nature. Right? Hybridization of carbon is triple bond is sp. That means 50% S and P. More the percentage, more is the electronegativity. Triple bond is more electronegativity. That is why it is better than the other carbons. That means basically it will lose H positive and negative charge is more stable on the sp hybridized carbon atom. Right? That is why alpha hydrogen, right? The alpha that not the alpha hydrogen, sorry, the hydrogen that is next to the this alkyne. This hydrogen, when you will lose this hydrogen, these electrons will jump here. You will have negative charge on sp hybridized carbon atom. That is the reason this is highly like proton donor. It is have very high acidity, right? Okay. So not the alpha hydrogen, but the hydrogen of this alkyne, right? Attached to the alkyne carbon is your acidic hydrogen, right? Last is polymerization reaction. So in polymerization reaction, what we do, right? This is polymerization, so very simple reaction. Like we had the polymers from ethene, we have the polymers from alkyne as well, right? So here you have polymer of alkyne at high temperature, polymerization will occur and you will have the formation of different big polymers here, right? Okay, okay. Cyclic polymerization, this is a very important concept and this is very frequently asked, right? Okay, very important, very important. Okay, mark it. Why this is important, right? Firstly, they can give you say 2-3 things. Firstly, how they usually ask, I'll tell you how usually the question is asked. Firstly, they will say you have CaC2 plus water. You will be like, yes ma'am, I know this reaction. Ethine is formed from here, right? Then they will tell you that you are doing the cyclic polymerization, but they will give you the reagents. And whenever you see red hot iron, usually red hot iron, right? Red hot iron, copper, quartz, or you have CoCO4 plus Br2. This is very rarely will be given to you. Mostly red hot iron will be given to you. Right? For example, simply RHT is they have written here. That means cyclic polymerization has happened, and you now know that there is formation of this benzene. Right? So in sequence reaction, they can start the reaction from CaC2 and then they will take you to the reactions of aromatic compounds. Right? So you should know these two reactions. So that is why this alkyne is very important. Usually it will be the starting product, right? Okay. Now let us see this here. Let us see this here. Okay. Now how it is done? So one pi bond will shift here, pi bond one here will shift here, one pi bond from here will be shifting here, right? You will have single bond there and one double bond here, one double bond here, one double bond here, and you will have the formation of benzene. Similarly, mesitylene also can be formed from here. For example, you have, wait a minute, I am writing one more example here, right? Okay, I'm writing one more example. So, for example, they have given you Mg2C3. You are hydrolyzing it. Now, tell me guys, what will be the answer? The answer, this is your JEE mains question only. I think JEE advanced question. This is your JEE advanced question only that I'm writing here. Right? So, this is, after this, you will have the formation of propyne, right? 1, 2, 3. This will be formed. Right, this is CH3. After this, what you will do? After this, what you will do? Everybody in the chat box, after this, what you will do? After this, what you will do, guys? After this, what you will do? Now, Here, the same way you will write it, C triple bond C, C triple bond C, C trip C, wait a minute, this is 1, 2, this C should be here and this C should be here, C triple bond C. Now I'm going to write the CH3, CH3. If I have written CH3 here, then here I'll write CH3 over here. Here I will write CH3 over here, right? Now, what will happen? One pi bond will shift here, one pi bond will shift here, one pi bond will shift here. And what will be the answer? What will be the answer? Very, very important. The answer will be one double bond here, one double bond here, one double bond here, one CH3 here, one CH3 here, one CH3 here. Answer is mesitylene is formed. Okay, mesitylene is formed. Got it? Got it everyone? Mesitylene is formed here. Bacha, everything is possible, okay? Everything is possible in this universe. Only if you devote full time, right? Then everything is possible. If you are going to waste your time, then nothing is possible, right? So give your 100% in these 4 months, then yes, it is possible. But definitely you should know at least the basics, right? Then that is possible. If your basics are not clear, then firstly clear them off. Instead of asking, start studying, right? Okay. Now guys, we have completed alkynes. We are going to start with aromatic compounds, right? Let us do aromatic compounds, that is benzene and its compounds, right? Okay, benzene and its compounds. After that, I'll give you break. Okay, benzene and its compounds. After that, I'll give you break. Okay, okay everyone. Okay, chalo. Now, let us start with the aromatic compounds. Aromatic compounds are basically which follows PCC, that means planar, cyclic and conjugated. There should be complete conjugation throughout. They should be cyclic and they should follow this thing. 4n plus 2 pi electrons should be present here. And a very important aromatic compound that we are going to study here is benzene, right? A very important aromatic compound is benzene that we are going to study here, right? Okay, so first is the structure of benzene. As you can see here, right, it has cacule structures that will firstly formed, that we usually write. Resonance hybrid looks like this, right? This also we write if you want to write the direct reaction. If you want to write the mechanism, then we write the cacule structures, right? So these are basically the canonical structures, right? Okay, benzene is found to be resonance hybrid of two cacule structures containing benzene ring are known as benzenoid. Now, all the aromatic compounds which contains a benzene ring, these are called benzenoids, right? And which does not contain benzene ring, that are called non-benzenoids, right? Okay. Next we have, these are the derivatives of benzene, right? Like if you have CH3 over benzene, that is called toluene. If you have CH3, CH2, CH3, that is called ethyl benzene. You have CH3, CH3 on the ortho position to each other, that is called orthoxylene. If you have CH3, CH3 on the meta position to each other, that is called metaxylene. If you have CH3, CH3 at the para position, that is called paraxylene. If you have CH3, right, not at ortho and para position to one methyl, basically they are adjacent to each other, 3 methyls are adjacent, that is simply cause 1, 2, 3. There is no common name for that. Common name is for xylene, for toluene here, right? Okay, and this I already told you, the name is mesitylene. If you have at alternate positions you have CH3, that is called mesitylene. Okay, that is called mesitylene. Okay, understood? Next, let us do the preparation of the benzene compounds. Okay. Chalo. Let us start this. The preparation, firstly, the preparation is the cyclic polymerization that we have already studied, right? So, with the red hot iron tube, this we have just studied in the properties of alkynes, that in this case, what will happen? Pi bonds will shift and you will have the formation of a aromatic ring. Mostly they can ask you benzene or they can ask you mesitylene. Okay, these two you should know how to form. So, benzene is formed from ethine and mesitylene is formed from propyne. Okay, mesitylene is formed from propyne. Next is decarboxylation of aromatic ring. So basically this is soda lime decarboxylation only. We know that in soda lime decarboxylation, if you have RCOONA, right, this will be converted to which thing? This will be converted to which thing, guys? RCOONA will be converted to RH. Same thing we are doing here. This is whole part is R. This is CONA. This is replaced by RH. So you have benzene ring over here, right? You have benzene ring over here, right? Okay, that is called decarboxylation. Then next is reduction of phenol. So if you have phenol with zinc dust, you are going to prepare benzene here, right? Okay, phenol in the presence of zinc dust, this OH will be eliminated by H, replaced by H, and you will have the formation of benzene, right? Okay, okay. Ma'am, in the cyclic is formed. Amarshwara, I think there is some mistake in the way you are asking. So I'm not able to understand what you are asking exactly, right? So next is some other methods for this. Some other methods are basically, if you have chlorobenzene, right, with the hydrogenation of chlorobenzene in nickel, right, then you will replace this chlorine with the hydrogen, right? Or you have with magnesium and ether, first you will have the formation of Grignard reagent, that is RMgX. Now Grignard reagent is very reactive in whenever you give it any proton source. That proton source can be water, that proton source can be any base, right? So whatever you give to this Grignard reagent, this MgX, if any proton source you are giving, this MgX will be replaced by hydrogen, right? So this is also how you can make from chlorobenzene to benzene, right? Okay. Also there is one more method. You can convert this chlorobenzene with the help of Dow's process. You can convert this to phenol. After that, with zinc dust, you can prepare benzene. So there are very different methods you can prepare the benzene, right? Next is some other methods. You have sulfonic acid, right? Sulfonic acid in presence of HCl, right? This thing will be replaced by hydrogen. Again, you will have the preparation of benzene. With disonium salt, you have NH3. Firstly, you will replace it. Firstly, there will be diazotization, N2Cl. Now, this N2Cl, if it is RN2Cl, in that case, so it is very unstable. Nitrogen will be liberated itself very easily, right? Just adding water. But here you need to either add good acid or you can just add water and warm it. Then this N2, wait a minute, that was no, that was the alcohol, na? Yes. So if you want to convert this disonium salt into benzene, right, that I was telling you was water and vomit, in that case it will be converted into phenol. Then phenol after adding zinc dust will be converted into benzene, right? But this we are not going to use. We are saying directly how to convert it. Directly you just need to add H3PO2. Then this N2Cl will be converted to hydrogen. That means benzene will be formed here, right? Okay, this reaction is also very important. This reaction is also very important. Okay, chalo. Okay, now let us see the physical properties here. Physical properties. Aromatic hydrocarbons are non-polar. First, let me see if any chemical property we are left with. In any preparation, decarboxylation done, phenol done, cyclic done, diazotization also done, Wittig reaction already you know, right? Okay, done. Okay, so now let us see the physical properties here. Physical properties, basically what you have, with physical properties what you have, aromatic hydrocarbons. Oh my god, what is this live going, huh? Are you guys even interested here? I sometimes feel I am like, why even I am teaching you? No person is interested in studying. Chalo. Physical properties. Aromatic hydrocarbons are non-polar molecules and are usually colorless liquids or solids with a characteristic aroma. Right, that is why they are called aromatic compounds. Right, they have a very good aroma. Aroma means smell. Right, naphthalene balls which are used in toilets. Right, whenever there is winter season. Right, or summer season, change of season, we use this. Right, then and for preservation of clothes because of unique smell of the compound and the repellent property. Aromatic hydrocarbons are immiscible with water but are readily miscible with organic solvent. Right, okay, with organic solvent they are readily miscible because they are also organic. Okay? They are also non-polar, so they will be soluble in not water because water is a polar compound. They will be soluble in non-polar only, that is organic solvents only. They burn with sooty flame, right? With sooty flame, right? They will burn with. Next, we have basically carbon, right? Then we have the chemical properties, and these chemical properties are very important because from here also the questions are asked. The questions are mostly asked from the chemical properties, or you can say some of the starting reaction. That means all that we are discussing here, na, the questions will be asked from these reactions only. The reactions that I am stressing over, right, from those the questions will be asked. Okay, I will also show you the proof. Right, now arenes are characterized by electrophilic substitution reactions. How? Now first thing is addition reaction. Will they show or not? I'll ask you why. Right, electrophilic substitution they will show, combustion they will show. Firstly, let us talk about the addition reactions. Right, firstly let us talk about the addition reactions. Will they show addition reactions or will they not show the addition reactions? Guys, if you talk about the addition reactions, will they show addition reactions or not? Just see this thing that you have a aromatic compound. Whenever you are adding something, if you're breaking one pi bond, you're breaking one pi bond here, what will happen? It will be converted into a non-aromatic compound, right? So from aromatic to non-aromatic, aromatic is more stable. That is why it is very difficult to show addition reactions, okay? It is very difficult to show the addition reactions. That is why they will hardly show any addition reaction, right? They need very drastic condition to show the addition reactions here, right? Okay. Next is this we have done. Now let us see the other reactions here that they can show. Okay, first is halogenation reaction. In halogenation, see, very simple now, so everything is very simple. Basically, we are talking about electrophilic substitution reaction. First thing is why they are showing electrophilic substitution reaction. Anybody in the chat box? Why they are showing electrophilic substitution reaction? See, if you talk about the electrophilic substitution reaction, electrophilic substitution reaction. Why they are showing electrophilic substitution reaction? Because this benzene ring here, right, it will have pi electron cloud all over this ring. All over this you will have the pi electron cloud, right? All over here you will have the pi electron cloud. That is the reason the electrophile will get attracted towards this pi electron cloud, and that is why they are going to show electrophilic substitution reaction here, right? So electrophilic substitution reaction, they are very useful throughout your organic chemistry, right? So just see what are the reagents. You don't need to get into the mechanism here. Just see what is the reagent, what is the electrophile that is generated. So when you talk about the halogenation reaction, here we take one Lewis acid, that is FeCl3. So that this Lewis acid, because it is electron deficient, it is going to take out the electrons from here, and FeCl4 will be formed, right? FeCl4 negative will be formed, and here you will have Cl positive. Now your electrophile is this Cl positive, right? This is Lewis acid, this is going to break the bond there and get, because it is deficient, so it will want to gain something, right? So that is why we are left with this electrophile, that is Cl positive. This electrophile, this Cl positive, will attack on any position and you will have the formation of chlorobenzene. Now I'll show you only one mechanism how this happens, because other things are same only. Okay, we are just taking a general electrophile, how electrophilic substitution reaction happens on any aromatic compound. So firstly what will happen, this pi cloud, right? Firstly what will happen, because of this electrophile, this pi electron will shift on the benzene ring. You will have this negative here, positive here, right? To this negative, you will have the attachment of electrophile, that will be here, right? Okay, and here you should not have this double bond, right? Double bond will not be present in this case, right? So pi electron has shifted here. With this negative, you have the attachment of electrophile, and here we all know that benzene is having 6 hydrogens here, right? That is why there will be one hydrogen also and electrophile also on this one, right? Now here we have positive charge and one hydrogen, because on each carbon you have one hydrogen, right? Now this is your arenium ion, right? The names are important. This is arenium ion. Now here we will make now sigma complexes. How to make it? This is one this is one structure. Resonance will happen, double bond, single bond, positive, electron will jump here, right? Double bond, and here you will have positive. Again, pi electrons will jump here as double bond, and here you will have the positive charge, because to this bond you have taken out the electrons. That is why positive charge will be present here. Now after this, these are the three resonating structures that you will have, and from this you have the formation of this resonance hybrid, in which you have electrophile here, you have hydrogen present here, and here you have the full pi cloud. And to more like if you want to show more things here, then you can say that on the ortho position you have the positive charge. This is ortho, para and ortho. On the ortho and para position you have the positive charge, right? Now what will happen, take any of the resonating structure, because things are easy when we understand this with the help of resonating structures. Now this H positive, because substitution it is, so this electrophile is going to replace one hydrogen over here. So that is why the hydrogen present here will be taken out, right, by the Lewis acid here, right? Now this hydrogen will be taken out. The electron of this carbon hydrogen bond will be shifted here, and you will have the formation of the electrophile substituted benzene. Okay, understood? Right guys? Okay, chal. Next is nitration. Now all the mechanisms are going to be same, only this the electrophile will change. In nitration, you have concentrated HNO3 and concentrated H2SO4, right? This is at around 55 to 60 degrees Celsius. Here, see, because this is a stronger base, so it will act as an acid, and this will act as a base. Though HNO3 is an acid only, but in comparison to this, this is less acidic. That is why it is going to, here it will donate H positive, it will accept H positive. So as you can see here, they have written this is the base, this is the acid, not because HNO3 is a base, because in comparison to H2SO4, HNO3 is a base, right? So here this is going to donate H positive, it will become HSO4 negative, and HNO3 is going to accept H positive. It will become H, this will be H here, right? Wait a minute, the H should be here. This is your HNO3, wait a minute. So see, H will attack here because oxygen now has 3 bonds. That's why there will be positive on this place, right? Now what will happen? This, from here, water will be taken out. How water will be taken out? This bond will be taken out by the oxygen here, and here you will be left with NO2 positive electrophile. That is why nitrobenzene is formed. Right? Nitrobenzene is formed, right? This is the same mechanism, just in place of electrophile, you will put NO2 positive. Everything else is same. Okay, everything else is same. Next is sulfonation. In sulfonation, you will have SO3H as. Now, this is a very confusing thing that in some books it is written as. See, in some books what they write? In some books they write that here SO3H is basically not the electrophile. Answer is SO3H only. In some books they will say that electrophile is SO3H. That is a neutral electrophile. But in some books it is, SO3, this will be positive. In some books it is written that SO3 is the electrophile. Right? Okay, but in your NCERT, SO3 is the electrophile, so I am taking SO3. Right? So, there is no proper clarification till now on this, that which is the electrophile. In some books, it is written SO3H, in some books, it is written SO3. And they will not ask you question on this complicated thing, right? Okay, so replacement of hydrogen atom by sulfonic acid. So, you have oleum, right? Oleum or sulfonic acid you will have, right? Okay. Now, from this, you will have the formation of this electrophile, that is SO3 or SO3H. If SO3 is attached here, see, if SO3 is attached here, what will happen? There will be internal transfer of H positive from this side, and you will have the formation of SO3H. I'll show you how internal transfer is done. So, this is your SO3. This is SO3 negative. Now, this is the internal transfer that I was talking about, right? Now, internally, this hydrogen will be transferred to this side. That is why you have the formation of SO3H. In some books, so they directly write that SO3H is the electrophile. But in some books, it is written properly that SO3 is the electrophile. After this, you have SO3 negative, then internal transfer of hydrogen will occur, then you will have SO3H here. Okay, understood? Chal. Now, next is Friedel-Crafts reaction, acylation and alkylation reaction. See, in both the cases, we will use Lewis acids. It can be FeCl3 and hydroCl, SbCl3, right? Okay, so now any protonating agents as well, like HF, H2SO4, H3, PO4. Now, what will happen? Basically, we need to make a carbocation here. Right? Here, write down one thing, rearrangement can occur. Rearrangement can occur. Because if you want to make cumene, cumene means isopropyl benzene. That will be formed by rearrangement of the carbocation. Right? So, like you have RX AlCl3, this X will be taken out by this Lewis acid, and you will have the formation of R positive here, that will act as a electrophile and will attack here. Like here you have the formation of CH3 positive, that is why you will have the formation of toluene here. Right? Okay, got it? Now, this is the same thing that I was telling you, right? Okay, same thing, same thing. Now, next is acylation. Okay, next is acylation. In acylation, isopropyl cumene, do you remember or do you want me to write that here? That was very simple, guys. So, when you have CH3, CH2, CH2Cl and AlCl3, carbocation will be this one. Now, rearrangement will occur, hydride shift, the answer will be this. This will be the answer. Now this electrophile will attack on the benzene and you will have the formation of cumene, right? Cumene will be formed, right? This is what I was telling you, right? Okay, chalo. Next is acylation. In acylation, what we have to do? You have RCOCl. The electron will shift here. Cl will be gone with the Lewis acid, right? Okay, so what you will have? See, Lewis acid will accept the Cl negative, right? And hence you will have the formation of acyl group here. Now this acyl group will attack on it, right? And you will have the formation of benzene COR, right? Okay. So basically to form ketones, we can use acylation for the formation of ketones, right? Okay. This is the same thing as I told you. Right now, this is important, the mechanism of Friedel-Crafts acylation. This also we have done in case of anilines. When I was teaching you amines, I taught you this there as well. That for amines, it's very difficult, right? Why this is very difficult for anilines? Because this is a very good base and this is a very good acid. So what will happen? Instead of reacting with instead of reacting with CH3Cl or CH3COCl, they both will react with each other and it will act as acid, this will act as a base and they will give us a salt and water, right? So what will happen here? This is going to attack on this lone pair and you will get the formation of a salt. Now this is a deactivated ring. That is why, because there is no resonance that will happen here. That is the reason. A deactivated ring means electrons will be taken out here. So that means electrophilic substitution is not possible here, right? Okay, so minus M group are attached to the benzene ring. For example, here you have these bonds. So what will happen? They will take out the electrons from this one, right? That is why minus I effect will happen here and hence electron density will be less. So electrophilic substitution is not possible here. That is the demerit of Friedel-Crafts reactions, right? Next we have aryl and vinylic halides cannot be used. If you are using these kind of halides, now what kind of carbocation can be formed? This carbocation will be formed which is not stable, This carbocation is not stable, right? If you have vinylic or arylic means this kind of, this carbocation you have. Now after this you will have phenyl carbocation. Now phenyl carbocation is also not stable, right? That's why this is not possible to take vinylic or arylic compounds. Then in substitution benzene, Friedel-Crafts reaction gives poor yield, right? When electron withdrawing group are attached on it. See, as I told you there, that why electrophilic substitution reactions are occurring? Why we have electrophilic substitution reactions? Because there is more electron density. Hai na? So if the electron density you are going to decrease on the benzene ring by having any electron withdrawing group here. This is electron withdrawing. You have attached electron withdrawing group. So this electron density over the benzene will decrease. So how come this is possible? Right? That is why the rate will become even slow. Right? Okay, addition reaction I told you, it is very difficult to have addition reaction. But two reactions are very important. Firstly, this gamazine or you can say lindane, right? Very, very important. The name is very important, right? The very small difference they will have, right? Very small difference. There is also one more reaction here, right? Same like this one only. So if you talk about the hydrogenation at 473 Kelvin, right? At a very high temperature, we are doing the hydrogenation. So when hydrogenation is done in drastic condition, then addition is possible. Otherwise not possible, right? Okay. So hydrogenation, if it is done at very high temperature, then all the pi bonds will break and you will have the formation of a cyclohexane. When you are doing chlorination in presence of UV light, then you have the formation of Gamazine. Gamazine means this is gamma isomer, right? Basically, benzene hexachloride. The name is BHC. BHC. The name is BHC. Okay? Chalo. Now I'll give you one more reaction here. I think that is not written here. So I'll just write it here. If you have chlorination, because there is a very small difference between these two. Chlorination in UV light, you will break all the pi bonds and Cl will be attached. But chlorination in anhydrous AlCl3. Here, you will have Cl on all the carbon atoms. Definitely, you will have Cl on all the carbon atoms. But there is something different that you will have. That is, the pi bonds will stay intact. Right? The pi bonds will stay intact here. Right? Okay? Okay. Yes, guys. So, all the pi bonds are intact. Chlorines are as it is. But in case of anhydrous Cl3, pi bonds will not break. There is just substitution that is happening. But in case of chlorination, substitution is happening and along with that pi bond will break and you will add H there. Right? Okay, got it? Everyone? Everyone? Chalo. So there is one more reaction. Right? There is one more reaction. Combustion, activating, deactivating. Chalo, this is so a different thing. There is one more reaction than one student was talking about, that is Birch reduction. Right? Birch reduction in case of aromatic ring. Right? Birch reduction. Now, how you will answer the Birch reduction? So guys, very simple. You have benzene ring. Right? Birch reduction, the reactants are going to be same only. You will have sodium in presence of liquid ammonia. Right? But here you will have the presence of ethanol as well. Right? Answer will be, first you draw this 6-membered ring. After that, double bond will be opposite. Either this way, or you can also draw this thing. You can also draw this thing. Or you can also draw this thing. Basically, double bond should be opposite. Right? These three things can happen here. Okay? These three things can happen here. Got it? Everyone, these three things can happen here. Got it, everybody? Everybody? Okay. Now, next important thing is they will ask you, what if you have electron donating or electron withdrawing group over there? Then what will happen? Now, if you have any electron donating group, acha, tell me if someone is donating you something, then are you happy or sad? And if someone is taking away something from you, then you are happy or sad? See, we all want people in our life who gives us something, right? Okay. So, here when someone who is giving you something, right, you will. Okay. So, electron donating, basically whenever you are donating something, so here what will happen? This is the cyclic ring, right? This is the cyclic ring, and here what you will have? Very near to the, like on the next position of the electron, because someone who is donating you, so you'll be happy, right? You want that person to sit like along with you, to help you, right? So this will be, they will be sitting together. But always remember, the answer will be opposite. Double bond will always be opposite. Here you can place it anywhere, but here it always should be next to the electron donating group, if there is donating group. Or the answer can also be, this is your electron donating group. Double bond, this is the next position, this is also the next position. Either here and opposite to this. Here and opposite to this. This is your Birch reduction. Then guys, you have this one. if you have electron withdrawing group, if you have electron withdrawing group, so with the electron withdrawing group, what you can have? Here, so you will have one only. Now we all want to stay away from someone who is like taking away everything from us, right? Okay, so what you will do here? What you will do here? Very happy na? Now here we are very sad. So when we are sad, we want to stay away from that person. So one step away, you will stay away from that person. And this is the double bond that you will have that will be opposite to each other. Okay, so this is called Birch reduction in aromatic rings. Okay, Birch reduction in aromatic rings. Okay, guys. Chalo. Now let us do one oxidation reaction also. Oxidation reaction also. Next is oxidation reaction, right? Oxidation reaction, oxidation reaction, oxidation reaction. So if you talk about the oxidation reaction here, oxidation reaction. So we'll see basically if you have on the benzene ring, right, you have any R group. This R can be anything, but the condition is this R should not be isopropyl. Okay, this R should not be isopropyl. Now, if you add KMNO4 here, what will happen? Directly, this whatever is this alkyl ring, this not alkyl group, this will be converted to COOH. Doesn't matter it is ethyl, propyl, hexyl, whatever it is. Okay? Okay. Okay, guys. Just write the condition here. Alkyl group. Alkyl group. Also add OH here and then hydrolysis. OH and hydrolysis. Okay. Chalo. Now, alkyl ring that I am attaching here. Alkyl ring, alkyl group should have alpha hydrogen. That's why I'm saying isopropyl it's not possible. This alkyl ring should have alpha hydrogen, only then this thing is possible, otherwise this is not possible, right? Okay, otherwise this is not possible. Okay ji, understood? Now one question that is asked in your JEE related to this thing, right? Let us do this question that was related to Friedel-Crafts only. So I'll do this here only, right? Let's do it here. Okay, chalo. So this question is asked in your JEE. That's why this is basically Friedel-Crafts only, but it's a different way of asking. You just need to have this group only, but here we will have this group can be from, we can have this group from anhydride also, carboxylic acid also. So based on that, we have a question here. The question says that you have benzene ring, right? You have benzene ring, and in this benzene ring, you have, okay, you have chalo, let's do this question as well. Let's do these two questions, okay? Chalo. Okay. Chalo, let's do this question. Okay. Now let us see this. They are saying that you have H2SO4. This is a different way of asking Friedel-Crafts acylation. Okay, this is Friedel-Crafts acylation only. You can have any proton donor source here. You can write here proton source. Proton source. So what will happen? H3PO4 also you can use. Right, proton source should be present here. Right, okay. Okay, yes. Yes, Ajit. Acha. Now, let us see what an acid does. Acid is going to abstract proton from that. Right? Sorry, not abstract. Acid is going to donate proton here. So, it will break this pi bond. So, what will happen to this electrophile here? How the electrophile will be generated? H positive will be added here. Right? That means positive H we don't need to write. So this pi bond will break, electrons will jump here, H will be attached here, and here you will have positive. This is the electrophile. This electrophile is going to attack here, and what is the answer that you will get here? Answer will be this benzene ring, right? And here you will have the addition of, to this carbon you are adding one carbon which is having two methyl group and one ethyl group. This will be the answer that you will get, okay? This will be the answer that you will get, okay? This carbon here is getting attached to this place, this carbon, so they will make a bond here. Rest is you have two methyl group and one ethyl group, okay? Rest is you have two methyl group and one ethyl group, okay? Chalo. One more question here, one more question. So you have benzene ring. This is same as Friedel-Crafts acylation only. It's a different way of asking Friedel-Crafts acylation, okay? So here you have double bond O, O, double bond O. Now what will happen? You need to have the acyl group. So what will happen? Electrons will jump here, and the electrophile that you will have is, this will be CH3 CO positive, and here you will have CH3 C double bond O, O, and this is negative. These two things you will have, right? Okay. So we know that electrophile is this one. So this electrophile is going to attack here, and you will have the answer, and you will have the answer as, this is benzene ring. On the benzene ring, you have the attachment of this C double bond O, CH3. Okay? Got it? Got it, guys? Chalo. We have completed this. Now I am going to give you a very simple trick, okay, on understanding which will be meta-directing, which will be ortho-directing, okay, because ortho-para-directing questions are also asked, okay. So let's see that. Chalo. First is the combustion. In combustion, what you will have, this you will add oxygen here. In complete combustion, you will have the formation of carbon dioxide and water, right? And this is the equation that they have given you. Now, we are not going to get into all these theory parts. I am just simply going to tell you a very simple fact here, right? Okay, this you can read yourself. Okay, I'll just give you the very important, these are the examples. So before examples only, here let's make a table, and in this table only everything will be clear to you, right? Okay, so you will be able to solve all the questions related to ortho-para directing, right? All these cases. Now see, how to identify whether this is a ortho-para directing group or a meta-directing group. First thing is, you need to see which is showing plus M effect, which is showing minus M effect. Plus M means it is going to donate the electron in the benzene ring. Minus M means it is going to take the electron from the benzene ring. So let's draw the benzene ring in both the cases. This is the benzene ring. This is the benzene ring. Now I am just simply going to show you that what is the how to directly see whether it is plus M or minus M. If you have a group attached, and that group has lone pair, right? One lone pair, two lone pair, three lone pair. Then what it will do? Wait a minute. Let me erase it only. Chalo, let's make a bigger structure here. 1, 2, 3. Chalo. 1, 2, and 3. Now see, very simple thing. If you have a structure, if you have a group that is having lone pair, right, then definitely these lone pairs will be donated to the ring if directly the atom attached to the benzene ring has the lone pair. Then it will donate the electron to the benzene ring, And you will see at ortho and para position you will have the negative charge, right? That is why plus M towards electrophilic substitution reaction, because electrophile is like looking for electrons. So electron density will be more on ortho and para position. So it will be ortho para directing. Okay. Next is, if you have a group, it may have lone pairs, it may not have lone pairs, but if directly here, right, okay, chalo. Now, do you directly have a group here and you have a double bond attached here and this is some X. Now, here what you will see that X is more electronegative as compared to G, right? The condition is if the group, that is the atom that is directly attached here, is further attached to an element which is more electronegative and they both are having double bond, then this is going to be meta directing. This is going to show minus effect. Reason is because this electronegative element is going to take the electrons from the pi electron. That is why this atom is going to take the electrons from the benzene ring. That is why it is going to show minus M effect, and hence you can write here that there will be positive charge on, not positive charge, positive charge on the ortho and para positions, and here you had negative charge on the ortho and para position. That is why here electron density is more on the meta position. That is why this is meta directing. That is why this is meta directing. From here also your JEE means questions simply based on this small concept they have asked the questions, okay? Simply based on these small concepts, right? Now guys, usually what will happen, generally ortho para directing is a deactivating. The group that is ortho para directing, that will be, activating group. That will be activating group, because it is making the ring activated by giving the electron, and meta directing is deactivating. But there is just one exception, and that exception is halogen, right? That exception is halogen. So in the exception we have halogens. Halogens, what will happen here? In halogens, what will happen? Basically, generally mesomeric effect is more dominating as compared to inductive, right? But when we talk about halogens, the case is completely opposite. That is why the exception we have. We know that here it is having lone pair of electrons. Whenever something is having lone pair of electrons, that will show plus M effect. It will donate the electrons. So this will also show plus M effect. Plus M effect means it is ortho para directing. That is also right. But in halogens, you also have, because halogen is very electronegative, so it is going to show minus I effect as well and plus M effect as well. Usually mesomeric is more dominating, so we just look for mesomeric and we answer that whether it's activating or deactivating based on the mesomeric effect only. But here inductive effect is more dominating. That is why though it is ortho para directing, but it is a deactivating group. It is a deactivating group. Okay, it is a deactivating group. Got it? It is a deactivating group. Very good. So till now we have done everything. Now guys, we are left with like a lot of questions I am going to teach you based on this, right? A lot of questions, but we will see the questions after the break, okay? We'll take break for 10 minutes and after that we will see the questions, okay guys? Yes everyone, after the break, right? So it will take us maybe 1 hour to complete the questions, right? Really amazing questions of JEE Advanced and JEE Mains as well. We'll see that. Okay, chalo. Okay, so till then I'll give you the break. So what's the time? The time is 4:37. So I'll join the class at 4:50 p.m. Okay, I'll resume the class at 4:50 p.m. Where should I write? I think I should write here only. Right? I should write here only, is it? Chalo. I'll resume, the class will be resumed at 4:30, not 4:30, it's 4:50 p.m. where we are going to do the previous year questions of JEE, okay, from this chapter, from hydrocarbons, right? Okay, chalo. So I'll see you all maybe after 10 minutes, okay, chalo. How many questions? I guess it 20, 25 questions maybe. 20, 25 questions. Okay, chalo. Okay, guys, and see you after the break, okay? Yes. Thank you so much, Aryan. Okay, so guys, welcome back to the class. Welcome, welcome. So now let us do the previous year questions. Shall we start with the previous year questions of hydrocarbons, everyone? Let us do the previous year questions of hydrocarbons, okay? Let us do the previous year questions of hydrocarbons one by one, we will see. Okay, guys? Chalo. I want all of you to participate in that, right? Otherwise, though, it will be a very monotonous thing, right? So, everyone do participate in that, and let me also inform the students on Telegram that we are doing previous year questions so that everyone can join here. Sure. Okay, first is which of the following compound is will most easily be attacked by electrophile. That means electrophile. That means you need maximum electron density on the benzene ring. You need maximum electron density on benzene ring. You should have maximum electron density on the benzene ring. Now, where you will have maximum? Firstly, let us talk about this group, and this group. We know that CH3 is having plus I effect, right? Chlorine, it will be giving you plus M effect and minus I effect, out of which plus M and minus I effect, which minus I is dominating. So this is your activating, this is activating, this is deactivating, that means it is going to take the electrons. We need maximum electron density, that means we need activating group, right? Deactivating group will be eliminated only. Third is you have two lone pairs here. It is going to give you plus M and minus I. But tell me which is more dominating, plus M and minus I. Plus M is, see, always plus M will be, not plus M, always mesomeric will be more dominating as compared to inductive. But if you have halogens, in that case, inductive is more dominating, right? So that is why this will become your activating group. Now, we have competition between, this is so definitely eliminated. Benzene does not have anything, so it is also eliminated. We have two activating group. You need to tell me which is having more activation power, second or third. See, here you have activation due to plus M. Here you have activation due to plus IE. So, mesomeric effect can show more activation of the ring. That is why phenol is going to be having the maximum electron density here. That is why it is activating maximum electron density. That is why it is most easily attacked by the electrophile. Right? So, answer is 4. Answer is 4 is the correct. Why CH3? CH3 is showing plus M effect, plus I effect. Here it is showing plus M effect. Mesomeric has most power as compared to inductive. Right? So, answer will be 4th is the correct answer. Okay. Next is you have given below are two statements. Two statements are given to you. First is the NH2 group is in aniline is ortho-para directing. So guys, firstly, so you need to tell me whether it's ortho-para directing or not. So if you talk about this group here, this is NH2, right? These are the lone pairs. We can easily see that on the group that is directly attached, you have lone pair, so it is going to donate the electrons. Plus M effect it will show. That means it will be ortho-para directing. So definitely this is going to be the right answer here, right? Next they are telling you Aniline does not undergo Friedel-Crafts reaction. That means aniline will not undergo Friedel-Crafts reaction. That is also true. We have just seen that. Why it is not undergoing Friedel-Crafts reaction? Because this is a base. In Friedel-Crafts reaction, you have Lewis acid. So they will react together to form salt. So that is why it will not show the reaction. So answer will be both, sorry, this will be true, right? So answer will be both statement 1 and 2 are true. Right, so answer 1 is the correct answer. Very good, Dev. Very good, Sarvesh. Very good. Very good. So answer first is the correct answer. And next question on your screen. What we have here? In the given reaction, they are saying A and B. You have two things. This is A that you need to identify. And this is B that you need to identify. These are the two things that you need to identify, right? If you talk about A, right, here you are using Diels-Alder catalyst, right? That's why it is giving you cis alkene. Here you are using Birch reduction. That is why it is giving you B. Birch reduction, that is why it is giving you B. In Birch reduction, you will have trans. Okay, so firstly, though, this B should be trans, not cis. So this will be eliminated, this will be eliminated. Right? Now answer can be 1 or 2. Now you want to make cis and you should have triple bond. So triple bond is present over here, not here. This is alkane. We make cis alkene from alkyne. So that means 1 will be the correct answer, right? Answer 1 is the correct answer, okay? Yes, so answer 1 will be the correct answer, okay? Yes. Chalo. Next we have the total number of deactivating groups present in aromatic electrophilic substitution. This is why the trick that I told you that will be useful to you here. That number of deactivating groups you need to see. Deactivating group means when they are attached to the benzene ring, they should have a group which is having double bonded with the atom which is more electronegative. So first you have is C. Here then you have, basically you have this thing. This is the group that is attached, right? So this is C, double bond O, OCH3, right? So definitely it is attached to a group that is double bondedly attached to a atom which is more electronegative. So it will show us minus M effect, right? What about this one? Here you have N, here you have N, which is H, then it is C double bond O, CH3. Now it is attached to an atom which is not double bondedly attached directly to oxygen. So here the lone pairs of this nitrogen will donate it here and you will have plus M effect here. This will show plus M effect, right? What about the other? What about the other groups? Here this is NCH3 CH3, you have NCH3 and H. Definitely it also does not, it is not directly connected to any double bond with more electronegative element. So lone pair will donate and it will donate here. So again it will be showing plus M effect. Okay, what about C triple bond N? 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 This is C triple bond N. Again, it is not double bonded, it is not triple bondedly attached. Now carbon, nitrogen is more electronegative as compared to carbon. So definitely it is also going to take away the electron from this pi bond and it is going to take away here. So it will show minus M effect, right? What about the last one, that is O, that is OCH3. Now this oxygen is not double bondedly attached to any other more electronegative atom. So it will not show minus I. These lone pairs will shift here and it will show you plus M effect. It will show you plus M effect. So answer is plus M. So how many of them are showing the Deactivating group, that means minus M, that is 2 groups. Okay, 2 groups are showing minus M effect. So answer will be 2 is the correct answer. Very good, 2 is the correct answer. Okay, 2 is the correct answer. Next we have, next question. Let me see how many of you can answer this. The question is 3-methyl-hextuene. You have 3-methyl-hextuene on reaction with HBr in presence of peroxide forms addition product A. The number of possible stereoisomer for A is, okay. So you have 3-methyl-hextuene. 1, 2, 3, 4, 5, 6. 3-methyl-hextuene. On hex you have second position, you have 2, right? So it is CH3. This is H2H3. Now they are saying you are adding HBr in presence of peroxide. That means here you will have anti-Markovnikov addition. Anti-Markovnikov or Markovnikov. Here you will have anti-Markovnikov addition, right? Anti-Markovnikov addition you will do here, right? So anti-Markovnikov addition means rich to rich, poor to poor. That means negative charge, the one that is carrying the negative charge, that will attack on the carbon having more hydrogens. So that means if I want to make the product here, this is CH3, CH single bond, CH3, CH2, CH3. So which is having less hydrogen? This is having less. This is having more hydrogen. So negative will be attached here. So Br will get attached here and H will get attached here. Right? Br will get attached there, H will get attached there. So that is going to be the answer. Now, next is product, the number of possible stereoisomers that it can have. Now you need to see this stereoisomers of this one. Now important concept about isomerism we have seen here. How to calculate stereoisomer? Firstly, so you need to see whether it's symmetric or asymmetric. Now firstly, so you need to see whether it's symmetric or it's asymmetric, right? 3-methyl-hex-2-ene. This is 3-methyl-hex-2-ene. Hex on the second position. And yes, okay, so now what you have seen that this is basically unsymmetrical in nature, asymmetrical. So whenever you have asymmetrical, then the answer of stereoisomer will be 2 raised to power n. What is this n? N is the number of chiral centers that you will have, because you don't have any double bond here, because in stereoisomer you calculate both optical and geometrical, right? Geometrical is not present here because we can't see any double bond here. So we will add only the stereoisomers or optical isomers only here, right? So basically how many chiral centers you have? This is the first chiral center, this is the second chiral center. It is 2 raised to power 2, that is 4 is the correct answer. Okay, 4 is the correct answer. Okay, 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 hex-2-ene only I have written now. 3-methyl-hex-2-ene. On the second position you have ene. तो सही तो है, it is right only, no? One, अच्छा, okay. Wait a minute, let me correct it then. Hex-2-ene, that means 1, 2, 3, I'll have one more CH2 here and CH3, है ना? Hex 3-methyl on third you have methyl, second you have 2-ene, and this is 1, 2, 3, 4, 5, 6, yes. Okay, now here also you will have one more CH2, right? One more CH2 and CH3, right? Okay. Okay, answer will be same only, right? So answer is your 4 is the correct answer. Okay, 4 is the correct answer, 2 raised to power 2. Here you don't have any geometrical isomer. What if you have any geometrical isomer? Then we will also add the geometrical isomer in calculating the stereoisomer. That is itself a different topic, right? Okay, so they have combined two topics here. So the answer is 4. Next, we have among the following total number of meta-directing functional groups. You have total number of meta-directing functional group is, you need to tell me. So guys, see, here oxygen is not directly attached. Oxygen is not directly attached to any lone pair, any double bondedly more electronegative atom, so it will show plus M. NO2 is definitely attached to a more electron donating, not electron donating. Here oxygen is more electronegative, nitrogen is less electronegative. So that is why it follows the condition where group is attached to an atom which is more electronegative. So it will show minus M effect. CH3 definitely it will show plus. It will show minus. It will show minus. Right? What about this NH? In NH, this is H, what you will have? C double bond O, CH3. Here also this nitrogen is not directly attached to a double bondedly more electronegative atom. So it will also show plus only because of this nitrogen, right? What about COR? COR is C double bond OR. So that is definitely attached to a more electronegative atom which is double bondedly attached to it. So that means it is going to show minus only, right? What about OH? It is going to show plus because there is no double bond with more electronegative element, right? What about COH? COH is C double bond OOH. Again, it is attached to an element that is more electronegative. So it is again going to show you the minus M effect, right? Minus M effect. What about Cl? Cl is also electron donate. It is deactivating, but it is showing plus M effect because it has lone pairs over it, right? So that's why it is showing orthopara directing. They are asking meta. So meta is 1, 2, 3, 4, 5, right? So 4, what I have taken extra? And not 2, acha 4 only. Okay, so sorry, 4 only. 1, 2, 3, 4. Huh. 4 is the correct answer. Okay, 4 is the correct answer here. Okay, guys. Next is the major product P in the following reaction. The major product P in the following reaction. What is the major product P in the following reaction? Now I am feeling that are you guys not even interested in solving the previous year question or what? Then what do you want me to do? The theory to I understand that, but why you guys are not even joining for the previous year questions? Previous year questions is so right now you must be doing previous year questions. Then why students are not joining for previous year questions as well? That is a big question on your preparation as well, right? Either so you guys are doing self-study, right? Or I really doubt your preparation. Chalo, the major product in the following reaction. Let us see the major product in this reaction. Let us see the major product here. As you can see, this is OCH2CH3. Concentrated HBr is used in excess. You have taken excess of concentrated HBr, right? Now let us see the CH2CH2. Wait a minute. Guys, just give me a second. Let us see. So sorry, an important call. I got an important call, that's why I turn off the mic. Right. The major product in the following reaction is, if concentrated HBr you will have. So what you will do, firstly, to when you have HBr, negative part will be, when you apply this on alkene, negative part will be attached according to Markovnikov rule. Negative part will be attached to less number. That means Br will be attached here, H will be attached here. This will be the answer. That means CH, Br, CH3. This will not be the answer. This also will not be the answer. Now the option is between 3 and 4. Right now this 3 and 4 is the option that we have. Right? Okay. Now let us see what we are going to do. This 3 and 4. Now what is going to happen with this OCH2CH3? What will happen? This is OCH2CH3. What will happen? This is positive, this is negative. This positive will attach to this oxygen. This negative will attach to this Br. And you will have the formation of OH here, not Br. Right? So answer will be 4th is the correct answer. Okay? 4th is the correct answer. Got it? Okay guys, 4th will be the correct answer. Right? 4th is your correct answer. After that, what we have? The arenium ion which is not involved in bromination of aniline. See, bromination of aniline. This is basically a question not from hydrocarbons but from amines, right? So whenever you are doing the bromination of aniline, the product, because it is ortho-para directing, the product is ortho-para directing. So in these 4 options, you'll see here also Br is on the ortho position, here Br is on the para position, here Br is on the meta position, here Br is on the ortho position. So where you see Br on the meta position, that is going to be the wrong answer, right, which is not involved. So meta is not involved because the product should be ortho-para directing, not meta, right? So answer C is the correct answer. Okay. Next is the final product formed in the following multi-step sequence is. So if you talk about the final product formed here, that is going to be, everyone, that is going to be, firstly what we are going to do, we are going to add water. So whenever you have this benzene ring, right, on this you have this alkene, okay. So you are going to add water into it. Water means break this double bond, attach OH, negative will be attached to, because it is acidic hydration. So basically you will firstly form carbocation. This is more stable carbocation. After that you will attach OH negative here. This is basically acidic hydration. After that you are adding CrO3, right? After that you are adding CrO3, which is a mild oxidizing agent. Mild oxidizing agent, what it will do? Mild oxidizing agent will convert this is mild oxidizing agent. Mild oxidizing agent, right? Now mild oxidizing agent will convert 2-degree alcohol to ketone. So here you will have C double bond O and this is CH3. Basically what you will have, if you want to write in this format, it will be double bond O here. It will be double bond O here, right? Now next is these 2 steps we have done. Third is hydrazine KOH. Now this is Wolff-Kishner reduction. Wolff-Kishner reduction. In Wolff-Kishner reduction, what you will do? In Wolff-Kishner reduction, this double bond O will be reduced to hydrogen. So this will be a ethyl ring here. So answer will be first is the correct answer. Okay. First will become the correct answer. Got it? First will become the correct answer. Okay. This is going to be the correct answer. Next is, in the given reaction, identify the reagent A. Okay. Try to solve it yourself. In the given reaction, identify reagent A and reagent B. I'll give you a hint that this is related to Itard's reaction, okay? Try to solve it yourself. Itard's reaction we are basically doing, we are converting toluene to benzaldehyde, right? Okay, toluene to benzaldehyde. There is some intermediate that is formed. Now, two things we are using. He is saying that firstly, so you are using CS2 here. So CS2, when you are using CS2, that is used in Itard's reaction along with chromyl chloride. So B will be chromyl chloride. A is not chromyl chloride, B is chromyl chloride. That is CrO2Cl2 or this. That means fourth and first cannot be the answer. Because in second option you have chromyl chloride and in third option you have chromyl chloride. Right? Now what is A? In A you are using acetic anhydride. So like same reaction, that was Itard reaction. Along with that we also had one more reaction that was similar to Itard's reaction. There was just one difference. That here you are using chromyl chloride along with CS2. Here you are using acetic anhydride along with the CrO3. Right, so answer is A CrO3, B is Cr2OCl2. So answer second is the correct answer, okay? Second is the correct answer, right? Okay guys, very good surveys. Second is the correct answer. Next you have compound A formed in the following reaction reacts with B, gives the product C, find out A and B. Okay. Okay guys, let us see what we are going to do here. Everyone try to solve it. What were the intermediate? Intermediate is basically a little bit, it was something, this is CH, it was OCrOHCl, not Cl, I think that was OCrH something twice, Cl only, HCl3 twice, something like this was the intermediate, okay, basically this was the intermediate, right? Okay, chalo. Now, next we have, compound A formed in the following reaction reacts with B, gives product C. So we don't know what is this A. We know one thing, that CH3C triple bond CH, when it reacts with Na, I told you when an acidic, because it is acidic in nature, when it reacts with Na, it will give H positive and itself it will be converted to H positive, will be replaced by Na. Now it reacts with some B to give this thing. So what is A? Firstly, so let us see what is A. A is definitely not this. A is also not this. A is also not this. Right? So A, so we can easily see this is A. Right? So there is not even any other option that we can say is correct. Right? But still we will see that what is B. Now when you have RNA, right, and you want to make double of the compound, right? Okay, you want to make double of the compound. Basically to this you are attaching this thing, right? Now I told you this is basically your step-up reaction. Step-up reaction. Do you remember we have just done this reaction, step-up reaction? I told you that this reaction is very important and they ask these kind of questions, okay? So here, step-up reaction, I told you after this when you have R dash X, this will be replaced by R dash. So which R dash we are using? We are using CH3, CH2, CH2, Br. Because if you use this thing here, CH3, CH2, CH2, Br, then this R will be replaced by this Na and you will get this answer, that is CH3C triple bond C, CH2, CH2, CH3. So B is going to be CH3, CH2, CH2, Br. So answer A is the correct answer. First is the correct answer, okay? First is the correct answer, right? Now, next question is, number of alkanes obtained. Everyone in the chat box, try to solve it yourself. Number of alkenes obtained on electrolysis of a mixture that is CH3CONA and C. So this is same as Wood's reaction, okay? Same as Wood's reaction. CH3COONA and you have C2H5CONA. Because we know that electrolysis always occurs via free radical reaction. Free radical reaction. It also occurs via free radical reaction. So what will happen? Double the R chain will be formed. So when this compound will react with itself, it will form CH3CH3, right? Because this thing will be eliminated, this thing will be eliminated. When ethyl, this R group will react with itself. That is your sodium salt of propanoic acid will react. Now these two molecules will react with itself. Then what will be the answer? C2H5, C2H5 and C2H5 and C2H5. Third is CH3COONA is reacting with C2H5COONA, right? When they are reacting with each other, then the answer will be CH3C2H5. That means you can have ethane, butane, propane. Three products can be there. Mixture of three products can be there. Okay, mixture of three products is possible, right? This is just like Wood's reaction. So mixture of three products is possible here, right? Okay, guys. Now let us see this question. Let us see this question. They are saying that identify A and B in the following sequence. You firstly have concentrated HNO3, right? Now, when you already have Br, you are adding concentrated HNO3. We know that halogen is ortho-para directing, right? So, at ortho and para positions, you will have NO2 because concentrated HNO3 means NO2 is the electrophile that you will have, right? So, answer will be at ortho and para position, you will have the NO2 group. That is only present in first case, right? So answer to we already know that answer is first is the correct answer. But still we will see what is B. Why B is this? Because after adding NaOH and Cl, once you have this thing, we know that it is difficult to break this bond. This C and Br bond, it is difficult to break because of it will have double bond character and so many things. But guys, we have at ortho and position, we have electron withdrawing group. So that is why the drastic conditions will decrease, right? We need a very like warming or by just adding NaOH and by just warming or adding HCl into that, we will have the answer. That means Dow's process, not exactly Dow's process. In Dow's process, we use high drastic conditions, but it is the same thing we are doing. But when we have electron withdrawing group, right, then we don't need that much high pressure, high temperature. So this Br will be replaced by the OH and answer is this one. First is going to be the correct answer now. Yes, B is the picric acid. Very good, very good. Very good. Okay, next question. Achha, let's see who can answer this first. Okay, let's see who can answer this question first. Number of isomeric products formed by monochlorination of 2-methylbutane. Monochlorination of 2-methylbutane. So what we have, 2-methylbutane means 1, 2, 3, 4. Monochlorination 2-methylbutane, that means CH3. You just need to know how many types of hydrogens you have, right? How many types of hydrogens you have. This is CH2, this is CH3. Now let us see. One product can be if you replace this hydrogen, right? So if you replace this hydrogen, the answer will be CH3, CH, CH2, CH3 and this is CH2Br. That is a different product. And I am saying any chlorination, monochlorination they are saying, I will just attach CH here. Other thing can be if we replace this hydrogen, this is also a different hydrogen, right? So answer will be entirely different. This is CH3, CH, CH3, CH, Cl and CH3. Entirely different product we have. Now third is we can also have this hydrogen. We can also have this hydrogen. Now answer will be very different. Answer will be CH3. I'll just write it here. Answer will be CH3. This is CCl, right? This is CH3, right? CH2, CH3. Now, last is if you have this or this, because they two are similar, they are like on the same carbon only, so they are same, right? They are same. But these two are same, okay? This CH3 and this CH3 is attached on only one carbon, so it is same only. So it will give you the same product, that is CH2. If I attach here, right? So it will be Cl here, right? Basically it's like this. C. If you're getting confused in that, you can also write it this way, okay? You can also write it this way. If you're getting confused by that, you can also write it this way. CH3, CH3. Now can you see that these two are same only, right? This is different, this is same only. These two are same only, right? So that is why they are going to give us CH2, Cl, CH3, right? Then you have CH, CH2, CH3. So how many products, how many different isomers you have? 4 different. 1, 2, 3, 4. So answer will be 4 different isomers you will have. Okay? Okay? If including stereoisomer is not given, what to do? Here they have not asked, here no stereoisomer they are asking. Right? Here so they are not asking any stereoisomer. In which case, stereoisomer they will ask you specially. Right? Okay? Right? Chalo. Now, wait a minute. Number of isomeric products formed by monochlorination of 2-methyl butane. Why our answer is coming out to be wrong? Number of isomeric product. One will be this. These three are same. These two are also same. This is also same. Right? Those two are also same. Monochlorination of 2-methyl butane will be 4 only. 4 only answer should be. 4 only answer should be. How come it will not be 6? It will be 4 only. Okay? Answer will be 4. Okay? Yes. Okay? That's including stereo. Including chiral carbon. Acha. They are asking the stereo as well. So if they see the stereoisomer, then what is the chiral carbon? They have not mentioned here isomeric product can be formed. So I to feel answer should be 4 only, right? Otherwise it will become a controversial question because they have not specified this as stereoisomer. They are saying isomeric products, how many it can form, right? So if we are focusing on the stereo also, then the chiral will be this one. The last one is chiral. Here you have this one is not chiral, this is not chiral, this is not chiral. You only have this as the chiral center. So it will give you 2 stereoisomer here. Right? Okay, it will give you 2 stereoisomer more here. Right? Okay? Including chiral also we are getting that. Na? 1, there is no chiral here. You don't have any chiral. Hai? Here also you don't have any chiral. Here also you don't have any chiral. Here you have 1 chiral. So it will give you 2 stereoisomer. Right? So it is 1. So it will be 1, 2, 3, 4, 5. So also then it will be 5 only. Hai na? Then it will also not be third one chiral. This one, which one? Third one means which one? Wait a minute. This hydrogen, 1, 2, 3. 1, 2, wait a minute. Bacha, here you will have, wait a minute. I think I have written wrong thing here. Wait a minute, let me just correct it. CH3, CH3, C, H, CH2, CH3. By mistake, I have written the wrong product. Now it's the right product. It is one, this is only one chiral carbon it is having. Right? Okay? Only one chiral carbon it is having. Second one, which one? There is only one chiral carbon. Okay? Okay? Yes, chiral is 2 carbon. 6 including. Yes, the second one is chiral. Which second? 6 is correct, ma'am. Chiral is second compound. Which compound? Second compound is chiral. Acha. Okay. CH3Cl HC. Acha. This is also chiral. Yeah. Now, any other chiral can you see? CH3C. Okay. No. CH2 no. This is C3. Okay. So 2 chiral we have. Yes, 2 chiral. So yes, the answer is 6 then. So 1, 2, 3. That means if you include stereoisomers here, that will be 1, 2 here, 1 here, and 2 here. So 2, 3, 4, 5, 6 will be the answer for stereo. है ना? Pink color wali compound. Okay, 6 will be the answer. But I still feel कि they should have mentioned here that they are calculating stereoisomers. है ना? Otherwise, so it will get confusing for the students. Right? Chalo. Then, next question is, you have this benzene. Now here what we are doing, we are adding NaOH alcoholic, then we are adding HBr ether. Okay. NaOH alcoholic, firstly you are adding. If you are adding NaOH alcoholic, they are asking that identify B and C and how are A and C related. So firstly, let us make the compound here, right? The compound is this one. The compound is, this is the benzene ring, and here you have Br, here you have Br, and here you have CH2Br. Okay, CH2Br. Now we are saying adding NaOH alcoholic. When you add NaOH alcoholic, can you tell me what will happen NaOH alcoholic? What is this reagent is useful for which thing? This reagent is a very useful reagent for which thing? This reagent is useful for dehalohydrogenation, right? So answer is this will be eliminated, this hydrogen will be eliminated. So here it will be, this is your compound, this is Br, and here you will have C double bond here, right? Firstly, this is going to be the answer for B. Br as it is, and double bond here. That means first is not the correct answer, fourth is not. Then option is between 2 and 3. Now after that you are adding HBr ether. Now HBr ether means what you will do? HBr ether means HBr ether. Now here what you are going to do? You are going to just add Br here now, है ना? Ether. Now Br will be added to less according to Markovnikov addition. That will be added according to Markovnikov addition. So here it will stay as it is, right? Br will also stay as it is. Now here you will have less number of hydrogen, because if you want to see the hydrogen here, it will be C double bond C, it will be CH2 here and 1 H here. So less number of hydrogen are present there. So it means Br will attach here and CH3 you will have it here. That means if you want to write down the product clearly, it will be CH, CH3 and this is CHBr. Now, this is your, wait a minute, that was B and C, right? This is B and this is C. So, this is B and this is C. Now, this also they have drawn it B and this is Br. This is the Br. So, it is the correct answer because here they are added it anti-Markovnikov addition. We need to do Markovnikov addition. So, definitely third is the correct answer. Moreover, they are asking what kind of isomerization they have. So, isomer, they are basically, this is the position is different, right? It's on this position Br and here Br is on the next position. So, basically the position is different. So, that is why they will be position isomer. So, answer will be C is the correct answer, okay? C is going to be the correct answer here, okay guys? C is going to be the correct answer. Got it, everybody? Guys, this is NaOH alcoholic. If they have given NaOH aqueous, then we would say this is the correct answer. But if they have given alcoholic, that means dehydrohalogenation will occur. Okay? Yes. H2, what's the difference between them? HBr in ether, just to confuse you. Okay? Because if they are written HBr simply with ether or simply they have written HBr, right, then you will do the same thing, Markovnikov addition. But if any peroxide linkage you will see, then anti-Markovnikov addition you will do. Okay? Yes? Chalo. Now, next we have, next question is, given below are two statements are given to you. This and this, they are saying nitration of benzene involved this step, where nitration of benzene, okay, this step will definitely happen, electrons will be shifted here and you will have the formation of NO2 electrophile. Yes, that is true. Use of Lewis base promotes electrophilic substitution on benzene. We are never using Lewis base, we are using Lewis acid only. So that is why this is not true, right? So this is false. So answer is statement 1 is correct, statement 2 is incorrect answer. Okay, statement 2 is incorrect. So answer is first is the correct answer. Now this I have taught you already. Let us see if you can answer this. I have taught, can you identify what is the reaction happening here? Can you identify what is the reaction happening here? Yes, students, can you identify the reaction happening there? Now, see this. This is benzene plus hydroquinone, right? Benzene you have here, right? Plus hydroquinone is double bond here, double bond O, double bond O, double bond O, 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 right? Now, let us see this reaction here, what will happen. So, this is like a N-hydride, right? You are using AlCl3 also. This is N-hydride. Now, I told you that in Friedel-Crafts reactions, in Friedel-Crafts reactions, right, they can also give you a different way of, answering that. Now, basically, wait a minute, what has happened? Where my mic has gone? Now, what will happen here? Any side, the electrons will be shifted here, right? So, basically, this bond will break and how it will attach here? How it will attach here? It's a very good question, okay? Now, this is the benzene ring, right? You can just make the benzene ring here. This positive, because when the electron, the bond will break, no, what will happen here? So, this is double bond O, this is double bond O, this is O. When the bond here will break, what will happen here? This will be O negative and this will be positive, right? To this, the positive side will attack on the benzene. So, basically, this carbon here is going to attack on the benzene. Okay, let's say on this position, it is going to attack here. How? Let us see. How? Let us see. Okay. So I am drawing this by pink pen. This is carbon. Carbon I have attached. Double bond O I have written. After this, one more carbon with double bond, one more carbon with double bond. Then you have one carbon with double bond O, and this is O negative. To this O negative, because here it has substituted the hydrogen, that hydrogen will come here. So this is basically nothing but this is COOH. Okay, this is nothing but this is COOH. So here what you will draw? Here you will draw, this is your benzene, this is benzene, and on this benzene you have C, or you can just simply write it that way also, double bond O, C, and this is COH. Okay, this is what you will get. This is A product. This is A that you will get. You can write here A. I think from A only you will be able to answer. Okay, benzene CO, COH. Benzene CO, they have eliminated CO. This is wrong. This is also wrong. And this is also wrong. So answer third is the correct answer. Right? But now you want to see that how ma'am other reactions worked. Now this is Clemmensen reduction. Clemmensen reduction. Right? With Clemmensen reduction, what will happen? With Clemmensen reduction, with zinc amalgam, right, and HCl, what will happen? This C double bond O of ketone, not of carboxylic acid, of ketone will be changed to CH2, right? So here you will have double bond O and this is COH. So this thing will be formed here, right? Okay, and yes. Okay, after adding H positive, right? After adding H positive, you will have the formation of, basically, after adding H positive, these C double bond O will combine with this and you will have the formation of double bond O here, right? Water will be eliminated from that side. Okay? Okay, yes, CO group to CH2. Very good. So answer is, third is the correct answer. Next we have the major product in the following reaction is. The major product in the following reaction. I am also your fan. I am also your fan. Okay. Now, the major product of the following reaction P. Now, this is, it should be liquid. Okay. This is not ING. This is liquid. Okay. Sodium in liquid ammonia. Remember what was this reaction? So, and here it should be triple bond, not double bond. It should be triple bond. Okay. Sodium in liquid ammonia. What is the name of this reaction? I want to see that in the chat box. What is the name of this reaction? And what kind of alkyne is formed here? What kind of alkyne is formed here? The alkyne formed is the alkene formed is transalkene. Yes, very good. Birch reduction. Okay. So now here what you will do? C triple bond CCH3. CH3 will be on the trans position to each other. Right. And after that, second is dilute KMNO4. Dilute KMNO4. But sir, do you remember in dilute KMNO4 what we used to do when you have alkene? Remember oxidation? Dilute KMNO4 is not a very strong oxidizing agent. It will give the answer of reductive ozonolysis. Break the pi bond, attach double bond O, right? And this is the answer for reductive ozonolysis. Right? This is the answer for reductive ozonolysis. Right? CH3, wait a minute, this is dilute KMNO4, no? Array, this is dilute KMNO4, this is Bayer's reagent. Bayer's reagent. What Bayer's reagent is going to do? What Bayer's reagent is going to do? It is going to, you can break this one bond and this will give you one OH here, one OH here, one CH3, H, one CH3 and this is H. So answer will be 2OH. Okay. 2 oxygen will be present here, right? Okay. Okay, the next question, guys. Next question on your screen. Try to answer it. Try to answer it. Yes, guys. Next question on your screen. Try to answer it. Chalo. Let us see. Arey, what will happen? Darne se nothing will happen. You have to face the reality, solve as many questions as possible, and trust, have faith in yourself. Okay? Have faith in yourself. Now, it's a very, very important question. Let us see that. Double bond here, and you have this triple bond here, right? One carbon, other carbon, triple bond, then CH3. Then you have CH3. Basically, I just want to write it like CH, C, 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 C. 4C you have. It 1, 2, 3. But how then I will write it as trans? Because we need to make the trans product here. No? So let's write it like that only. So it is C triple bond. This is C. And then again you have one methyl group. Okay. Now you are doing the Birch reduction. In Birch reduction, because see, they are asking you the isomers here, right? So for isomers, you need to see cis and trans. The isomeric tetraenes, not including sp hybridized carbon atoms, right? So you need to see cis and trans here, right? So trans product will be formed, and this will be converted to trans product. So how it will be converted? You will have this ring here, right? It will be a double bond, right? Then here carbon, here you will have double bond, right? Double bond, and here you will have one methyl group. So one hydrogen will be present here, one hydrogen will be present there, right? Benzene, directly you are saying benzene. One carbon, other carbon, 1, 2, 3, 4. 1, 2, 3, 4. Yes. 4 carbons we have. Trans product means this side also, upper side, downside. Here hydrogen you have here and here. That means definitely it is a trans product. Okay, we're just checking trans product only. No? Then we are adding Br2 in excess, right? Br2 in excess. Br2 excess means all the double bonds will break, right? And you will have the attachment of Br. Okay. So double bonds will break, and hence you will have the attachment of Br here. So let's attach Br here. Let's attach Br. Okay. So let's attach it. This is benzene, not benzene. This is like double bond, right? This is Br. This is Br. Here you have this Br here and Br here as well, right? Okay, so this is how you have all the compounds. Now, then they are saying that you are adding KOH alcoholic. Now, on adding KOH alcoholic here, now what will happen? On adding KOH alcoholic, what you will do? You will take out basically dehydrohalogenation you will do. Right? That means halogen will be eliminated, hydrogen will be eliminated from this side. Right? No, not benzene. Now hydrogen is eliminated, hydrogen and hydrogen is eliminated from this side, and double bond will place here. One double bond here, one double bond here, one double bond here. Okay, so those 4 double bonds we can have. Right? One double bond here, double bond, right? Because halogen and here hydrogen will be eliminated. From here halogen is eliminated, from here hydrogen is eliminated. Again from here halogen is eliminated, from here hydrogen. from here halogen, from here hydrogen. So this will be 1, 2, 3, 4, and it is your double bond here as well, double bond here as well. So this is your first isomer, right? Other isomer that we can form here, guys, one more isomer that we can form here. Wait a minute, one halogen from that side. If we can make double bond Br, wait a minute, Acha, Br was not present here, Br was present here, Br was present here. So here I am saying this double bond is present here, right? So here the answer will differ, right? Because now Br will not be attached here, Br will be attached over these two places, right? Okay, so that means here you will have Br and here you will have Br. So Br will be eliminated from this side and this side hydrogen. From this side Br, from this side hydrogen. So here double bond will be present here and here, right? Now two double bonds you can have, either this one that is on a cis position, right? And one more structure you can form here is this one, right? And here the other, this is basically the double bond, no? So this is the double bond, this is the double bond. Now from this hydrogen is present here as well and here. So this is trans position. I want to also make cis position here. So cis position will be where hydrogen is present here, hydrogen is present here. Then the next group is present here only. So it will be 1 and this is double bond like this. Okay. So this is the cis position, where two hydrogens are on same side, here two hydrogens are on the opposite side. So these two compounds we can make. Okay, so two isomers, cis and trans isomers we can have in the end. Okay guys? Okay. Okay. Okay everybody. Got it? So answer will be 2. Okay, answer will be 2, right? Answer will be 2 is the correct answer. Okay, already written the answer here. What will happen? Okay, got it? Got it everyone? Chalo, let us do the next question. Chalo, let us do the next question, that is total number of hydroxyl groups present in a molecule of major product P. Right, the major product is P here, right? They are asking you total number of hydroxyl group that are present here, right? So firstly, what is H2PD? This is basically your Lindlar's catalyst, and cis alkene will be formed here, right? So basically if I draw it here, double bond if I am drawing here, and then you have cis alkene means this is the double bond, right? So here you want to draw double bond, this is over here 1, 2, 3, 4, 5, 6, right? So after this, which position you have? 1, 1. If I call this first, second, third, so on the third position you have double bond. 1, 2, 3. Third position I'll have the double bond, right? Okay, third position I'll have the double bond. Here what you will have? This will get converted to double bond. And here on the same side you will have pentene, right? Pentene. But here on which position? One, second position. If I talk this as first, this is second position. Here you will have the double bond, right? Now they are saying once you have cis dilute KMNO4 excess you are adding. Basically you have 3 bonds here, right? You have 3 bonds here. Arre yaar. Okay, you have 3 bonds here. Firstly, this bond you will have, shall I just write it there? But okay, then you will see, ma'am, we don't have the answer. Now this is the double bond, this is the double bond. To this double bond, you will have the addition of OH, OH, right? See, one OH is added here, one here, one here, one here, and one here, one here. So easily you can see 1, 2, 3, 4, 5, 6 OH are added, right? You don't even need to make the answer, like make the compound here, right? Write the answer. You just know that, okay, 6 OH will be added here, right? If you want to have the full-fledged answer here, it will be OH, this side OH, this is benzene, right? Not benzene, why I'm saying benzene? OH, what love I have for benzene. So basically 6 OH groups you will have, okay? 6, this, so you don't even need to make this product. You see, this is double bond, this will be converted to double bond, this is double bond, so each double bond will have 2 OH, so you will have 6 OH. So directly also you can answer, but still if you want to know the exact, like what is the product, so I just do this for you, okay? Next is the major product U in the following reaction is, right? This is the very simple, you can easily answer this, okay? Easily answer this. So, do you want to do this in the homework, everyone? Do you want to do this in the homework? Do you want to do this in the homework or not? No, ma'am, you only teach us this. Ma'am, we don't want any homework. Okay. Now, you have benzene, right? You have benzene. This benzene, this is CH2, double bond CH, CH3. You have a proton donor here, right? Okay. I told you whenever you have a proton donor, this pi bond will break. This pi bond will break. This pi bond, pi electrons will shift to this side because here positive will be more stable. So here you will have one hydrogen, right? So here you will have one hydrogen like this. After this, what you're going to do, everyone? What you're going to do, everyone? After this, what you're going to do? Then this electrophile is going to attack on the benzene ring, right? This is the benzene ring. Electrophile is going to attack. Answer will be on benzene. Tell me, what is this product called? What is this product called? CH3 isopropyl benzene. What is the common name? The common name is cumene. Okay. Now, after this, after the radical initiator O2, right, what will happen? Radical initiator, this peroxide linkage will be there and you will have the formation of this thing. I'm just writing it here, CH3 twice. After this, you will have the formation of peroxide linkage. So, answer will be, wait a minute, benzene, C, CH3, OOH. So, B is going to be the correct answer, okay? B is going to be the correct answer, okay? Yes. Okay, guys. Chalo. So guys, that was all about hydrocarbons. Now I would love to see your comments that what exactly you want for your JEE mains, right? Do you want me to pick questions only, right? So then I'll start question series here, questions of full previous year questions of JEE mains. We will put some JEE advanced questions also which can be asked in JEE mains, right? Okay, and some related question also I'll pick. So let me know in the comment section what exactly you want, right, for the next coming 1 month, so that we can have a very good preparation for your JEE mains first attempt January 2025. Okay, yes. Okay then guys, bye bye, take care and see you all in the next class, right? And I'm waiting for your comments. Ma'am, previous year questions. Okay, Ultra, I want other students also to write it in the comment section what exactly they want, and those students who were not here, right, they are watching the recorded version. I am waiting for your answers in the comment section, right? Okay then, bye bye, take care, see you all in the next class where we are going to start previous year questions. I'll start that, right? And what else you want, right, that let me know in the comment section.